founder and also marketing director of HelloBio and host of this event. Together with me today, we've got the lovely Alice Reeves, our event manager, who's going to field and manage the questions. We've got Hannah, who is going to keep everyone posted on Twitter. And in the virtual audience somewhere, we've got some other members of the HelloBio team, James Flanagan, our product director and co-founder, and Matt, who does a lot of work with our antibodies in the product team. And he recently got his PhD in pharmacology. In terms of you guys, thank you so much to everyone for joining us today. We're really delighted to get everyone together, and we will have delegates here from all over the world, literally all over the world: Finland, Belgium, India, Portugal, Germany, Israel, France, New Zealand even. So that's just fantastic. So I'm not going to talk for long. I was just going to give you a little bit of intro to HelloBio and tell you how and why LabLifeCon was born, give you a few practicalities about today, and obviously introduce our wonderful speakers and panelists. So firstly, HelloBio, who are we? About 6 years ago, a group of friends who happened to be researchers and manufacturing chemists got together and set up a company whose aim was to support researchers. So I'm a PhD pharmacologist. My husband, who also happens to be the managing director, is a PhD chemist. So as you can see, we are a very happy bunch. I did actually find it quite hard to get some recent pics of us all together, as you can imagine. But here's just a couple of snaps, either sort of in between or after COVID lockdowns. And our PhD and postdoc friends had been complaining to us that everything in the lab was so expensive, and they were often struggling to get funding, and we actually saw a way we could help. So we were able to launch a range of high purity biochemicals that were really low priced, and we were aiming to be around half the price of everyone else. But at the same time, crucially matching or bettering the quality of those other suppliers. So this was really well received and still is, as you can see, and it's something we're really proud of. We've supported thousands of researchers around the world, and we've now got offices in the UK, the US, and Europe. And we've also grown our range considerably since those early days, manufacturing biochemicals and reagents to support different areas of research. So I've put a few up here: chemogenetics, synaptic signaling, stem cells, CRISPR, you can see it all there. And our most recent adventure into the antibody field, we're really excited to launch our new ValidAb range of data-rich antibodies, but still very much keeping with our philosophy of offering researchers the most affordable price. But although our initial focus had been on supporting our friends pretty much with physical products, we soon realized that we could actually support our colleagues in other ways. We've all worked in labs, and we understand the emotional and logistical challenges researchers face on a daily basis. So we then introduced what we could. So monthly travel grants, early career scientist grants, which you guys are all welcome to apply for, and you maybe already have. And over the last few years, with the help of some extremely supportive and articulate and lovely researchers from the science community, we've built our blog, and we've collaboratively created our guides for life scientists and grown our annual Lab Heroes Awards, with the aim of helping researchers to thrive and flourish personally and professionally. So for those of you who may not be aware of it, I will just give a little plug. There are some great resources over on our blog on a huge range of topics: PhD help, careers, coping with rejection, parenting in science, lots more. So hop over there and have a look sometime when you can. And I might also add, if anyone would like to contribute an article to the blog, please do let me know. So I'm sure you may well have learned lessons from your own experiences that you would like to share and help your colleagues. So we'd love to hear from you. Next. So that brings me on to LabLifeCon, what we're doing here. So we're always inspired by the incredible spirit of camaraderie amongst scientists and the huge willingness to help each other navigate life inside and outside of the lab. So we thought it would be great to ask some experts to come together to share their knowledge and give early career scientists a chance to interact and ask questions in a really friendly, non-judgmental forum. So what do we have in store for you today? We have got 15-minute TED-style talks with question and answer sessions, 2 30-minute panel discussions, and we're thrilled that we've got Dr. James Quinn and Jasmine Benjamin, who have kindly agreed to be our early career scientist chairs for these sessions. First up, we'll hear from Professor Stuart Maudsley from the University of Antwerp in Belgium. So mentors are a crucial element of your scientific career, and they come in all shapes and sizes. And the vast majority of mentors really want to help their students. But it's vital to have a respectful and effective line of communication for that successful and productive relationship. So a little bit later, Stuart is going to give some valuable advice on establishing and maintaining these relationships in our opening keynote talk on getting the most from your mentors. That will be followed by our first panel discussion. What should you consider when writing scientific papers? Where can you get them published as an early career scientist? And what's the best way to go about it? What about peer reviewing papers? How do you even get started there? So panelists, Dr. Matthew Lloyd from the University of Bath and Dr. Bronwyn Martin from the University of Antwerp are going to share their expertise and help answer those questions and more in a discussion chaired by Dr. James Quinn from Massachusetts General Hospital. And then a short break after that will lead us on to our next talk on failure, resiliency, and overcoming imposter syndrome. So it can be incredibly difficult to find strength when facing setbacks in academia. So Dr. Matthew Cayley from Queen Mary University of London is going to share his own experiences, his career journey, the setbacks he faced along the way, and will offer his advice on staying strong when things go wrong. Then we have another panel discussion. So writing successful funding applications. So what makes the difference between a successful and an unsuccessful application? And if it's rejected, what should your next steps be? So panelists, Dr. Enito Bafor from the National Cancer Institute, Professor Patricia Maciel from the University of Minho, Portugal, and Dr. Bronwyn Martin from the University of Antwerp in Belgium will consider these questions and in a panel discussion chaired by Jasmine Benjamin from the University of Alabama at Birmingham. Another break, and then we are on to the topic of burnout in science. So what even is it, and what is the difference between burnout and depression? Dr. Olya Vedenskaya from Dragonfly Mental Health will look at the core components of burnout, present evidence-based strategies to treat the symptoms, and discuss how to prevent work-related stress. She'll also provide an overview of the burnout cycle and how to break it. And then that will bring us on to the final talk of the day, which will be on STEM career paths for life scientists. So you have a degree or a postgraduate degree in science, then what? How can you find out what you like? It's never too late to start thinking about career paths and plans. And in her talk, Dr. Joanne Kamens, a senior consultant at the Impact Seat, aims to inspire and provide specific tactics for charting a course for that happy and long-term career in science. So that's, I've just got a summary here of the schedule, but this can also be seen in the reception area of Hopin, which is the platform we're on now. And talking of Hopin, I'll just give a few practicalities to help with the day. So the sessions will be recorded and you will have access to those recordings for at least 30 days after the event. I'll keep popping up and we'll introduce our speakers before each session. And then I'll leave it to our lovely chairs to introduce themselves and their panels. On the left, I think, of your screen, you've got access to 3 areas. You've got reception, stage, and people. So the reception area, that's got the schedule on it and information about the speakers. And the stage is in essence like the conference room if we were all together in real life. It's where the talks and the panel discussions will be taking place. So you need to make sure you're in the stage area to view the talks. But if you can hear me, then I guess you have already found that area. If you access the people area, you'll be able to see who is here, and you can message and connect with anyone if you wish. Just to say, we're really keen to keep this all very informal. So our speakers, they're extremely approachable, lovely people, and the power of these events will be in the questions. So there's no such thing as a stupid question. So please just dive right on in and make use of those talented people. And in terms of how the questions will work, it's very easy. If you have a question for the speakers or the panels, just type your question into the Q&A box on the stage, and either Alice or our panel chairs will pass your questions to the speakers. If you've got a general comment, you want to share any thoughts with everyone, you can use the chat. And keep your eyes open for any polls or little surveys that we send to get a bit of feedback. And that will help us improve, make this work for others as well. Now we've scheduled a couple of breaks. So during these, we'll turn off the cameras and microphones, but the event chat will remain live so you can carry on chatting. Right, now then I think, what have we got? Oh yeah, so this is just like an overview of what I've just said there. The important thing, if you want to ask a question, go to the Q&A and type your question in. Or again, if you just want to chat, make a general comment, say hi, you go to the chat. And if anyone's got any technical problems, then you can click people and find Alice Reeves, and you can message her, or you can pop any problems over in the chat and we'll try and sort it out for you. Okay, so I thought we've got a few minutes. I thought we could just have a go and try a few things. So if anyone's got a question for me now, they can pop over to the Q&A on stage and type in the question. And then maybe everyone could just type a hello message, say where you're from maybe, just to check that's all working. And I will also, I'll leave the stage and I'll go and try out the poll and send something out to you. So you'll hear from me in a bit because I'm going to introduce Stuart. Yeah, go and have a go on the chat. Thanks very much, everyone.
Hello, Stuart. Welcome. Over to you to introduce yourself and your presentation.
Okay, well, thank you so much. A tremendous thanks to Alice, Hannah, and Sam for inviting me to the LabLife Con. And I really hope that we have a great discussion today. And so, my name is Stuart Maudsley. I'm the Odysseus Professor of Receptor Pharmacology here at the University of Antwerp, and I run the Receptor Biology Lab. And I'm going to be talking to you today about mentoring. So, as you can see from my grey hair, I'm quite old. And I've had quite a lot of students of all different types from different places and different backgrounds. And so I'm trying to give some of my experience to you with respect to finding and forging this relationship, which is probably one of the most important relationships in science. I wholeheartedly feel that the ability to form this bond and to use it productively is what really drives science more than anything else, perhaps, even more than technological advancements. So having this communication and this human link is vital, and I'll try and show you how important it is. So let's go back in history as usual. So here you can see two slides. So here we have, on the left-hand side, we have this young chap. He's Telemachus. He is the son of Odysseus. So Odysseus was the Greek hero of the Odyssey and the Iliad. So Odysseus spent 10 years in the Trojan War, 10 years coming back. So tremendous journeys. And so while he was away, he had his friend, mentor, look after Telemachus and help him and his mum Penelope. So this was one of the first classic books ever written, and it indicates how important the wise influence of mentor had with Telemachus, and this is indeed why we call mentors mentor, because basically he was the archetype, and this was like 700 BC. So when I was a kiddie, I really loved manga. So I actually watched a whole series, which is a French-Japanese series called Ulysses 31. So they transported Odysseus or Ulysses into the 31st century and retold all these great stories of returning from Troy back home in sort of modern sci-fi context. But it just shows you how important these stories are. This is one of the oldest stories that we know. And implicit in the story is like learning knowledge from wise people. So this is what mentoring is all about, and this is why it's so important. It is the scientific process, I do sincerely feel. So let's start off by looking at some of my students. And so these are a whole bunch of students that I've had recently here in the receptor biology lab, a whole variety of different types of people, all with a drive to do science. And each one of them is a unique individual with a unique set of talents and skills and also different personalities. So dealing with them all is incredibly enriching as a supervisor. So it's really vital to understand and get on with as many different types of people as possible. So you are here. So as you can see, we are trying to position ourselves in the world of science. So when you're young and when you're starting out, you are sort of, okay, how do I fit into this great world of science that exists? So the interesting thing is quite recently we started doing these mentor trees. So this is a representation of just a small part. So this bit here at the top, you can see is my current mentor tree, and actually down below is the actual full size of it. And this is from academictree.org, where you can go and situate yourself amongst all of your previous mentors. So as you can see, I'm in sort of red here, and this is one of my great mentors was a guy called Bob Lefkowitz, and so I did my postdoctoral fellowship with him at Duke University in the States. But then if you then go back in the tree life, you can go further up the tree here, and you realize that you're connected to all these amazing people that you never thought you were. So here is Auguste Kekulé from the structure of benzene. This is Robert Bunsen, for obvious reasons. You might notice Erwin Schrödinger, Max Planck, and finally Justus Liebig. All these great chemists and these great thinkers and these astonishing people, and I'm connected to them. And it's quite remarkable to think that this mentoring process glues people together and brings people over hundreds of years to be part of an organization, part of a structure. So when you're a scientist, you're joining this sort of tree. So you should feel very proud and interested in where you're going. So, amazingly enough, this is how we're going to talk about mentoring. You'd never guess it. And this is one of the important aspects I like to try and introduce, is that to get to know your mentor is a very important thing. So you have to make a choice of what that mentor is like and appreciate them. So the way I do this with students is I just give them my personality and say, hey, this is my own personality and this is my science personality. The way I am is the way I do science. So amazingly enough, all of these images, we're going to take us through the world of mentoring. So you never know where you're going to start off. So the first thing is choose your mentor wisely. It seems very, very obvious. But if this relationship goes well, it's going to stay with you forever. I started being mentored by other people over 20 years ago, and I still know them personally and intellectually to this day, and I'll never stop working with them. So it is incredibly important. So the most important things to look for is a compatibility of mentality and a compatibility also of personality. If you're different personalities, it's going to make it very difficult. So try and engage and understand what makes your potential mentor tick and also what makes you tick. So your journey will not only be a journey of your relationship with your mentor, but also of your own interaction with science and also with your own personality in life. I would say that was a very strong influence in me. It was going away to be a scientist and then realizing exactly who I was. So when you work out what you are, you can understand what you're compatible with, and then you'll be able to find a mentor that actually is really good for you. So you want to find one that inspires you, that makes you laugh, you're interested in working with. So all of these features, try and do this in as many dimensions as possible. Don't just do it for the type of research that they're doing, because that's likely to change in a few years' time. So look at every aspect of their personality and every aspect of their work. Try and find compatibility. It doesn't have to be exactly the same, but has to be sort of compatible. You don't want to rub up against each other all the time. So it's very clear to make these good choices. So the other important point is don't have just one. Don't just have one mentor. A mentor can be from anywhere. Clear, we always have this idea of the individual specific scientific mentor, so me with my old mentor Bob Lefkowitz, but I had many other mentors at that time. So I had mentors for certain aspects of science, mentors that I would talk about with respect to how to publish or how to write or how to do a new piece of skill, or a mentor that could sort of give me advice from an emotional point of view, or a research point of view, or a presentation point of view. So try and get as many arrows in your quiver as possible. Don't limit yourself just to one voice of advice or one person as a mentor. You can have a primary mentor, but then look for advice and look for wisdom in as many different places as you can find it. It really does help tremendously when you get this sort of quorum sensing capacity, when you have reliance on input from as many different potential mentors as possible. So never feel bad about having more than one. That's perfectly okay. So, as you can see here, you have to think both what's just in front of your feet, but also what's at the end of the journey. So in science in general, you always have to have a plan and goals. But just as important to your research is your interaction and your relationship with your potential mentor or mentors. So what you want to try and do is you want to try and see, when you start off with a new mentor, is what can we achieve with respect to this relationship in a short term. So can we, from an experimental point of view, can we set things up, and then can we see how that process goes and see how the relationship starts off. But also think about the future. So we'll get to this later. So science moves so quickly, and hopefully part of that moving so quickly will be your advancement of science. And that really does come from the relationship with your mentor. I can't tell you how important that relationship is, because your ability to be creative or your ability to drive yourself is really dependent on the ability for you to maintain that desire. And a large part of that can come from having good mentors, both at the intellectual level, but also at the emotional level as well. Because if you're not feeling happy, if you're not feeling fulfilled, your brain's not going to work too well. So consider your relationship with your mentor, both from a short-term goal point of view, but also from a long-term point of view. Because hopefully what you want, and this is why you choose wisely, is to maintain this relationship for almost the rest of your life. It's like no other friendship. It's sort of like a friendship, and it's an intellectual journey. It's really one of the reasons I got into science, was to join this sort of group, this academic tree. I think it's a fabulous institution. So, one of my favorite things. So the important thing, especially, and I've said this a million times, is communication. This is what Sam alluded to before. And when I was a student, I basically lived in the doorway of my PhD mentor, Dan Donnelly. I would spend virtually half of my day in there talking to him about my results and what I was doing and what I wanted to do next. I'm sure I probably annoyed the hell out of him, but I was desperate to get feedback. I really wanted to know. This is the important thing when you start off in science as a mentee and as a mentor as well, because it actually goes both ways, this relationship. So as a mentee, you will educate your mentor, even the best ones. And as a mentor, you'll be educated by your mentees. So you're actually improving each other. So always try and maintain the feedback, both from the mentor to the mentee and vice versa. So this is important from a point of view of science, but it's an important thing from a point of view of regulating and maintaining the positivity of this relationship. So often problems can arise when there's periods of non-communication. But if you keep this on a daily basis, and even if it's just popping your head around the corner and saying, hey, how you doing? Spend a few minutes time discussing something, discussing a bit of science, that is the way to keep it going. Every day, small bits. So when I was a postdoctoral fellow, I went to one of the biggest laboratories in the world, and I was amazed that virtually no one was inside the lab, everyone was outside the lab, and they were talking. And I was thinking, what on earth are you doing? And I realized that actually it was the talking, and it was the constant, slow feedback between one person to the other, and then to the mentor, and then back down again. This constant feeding and checking is like a sensing mechanism to make sure everything keeps going, and the oil sort of lubricates the engine. So it's very important things to keep this quick line of communication with your mentor. So, as I said, talking is excellent, but also the really important thing is to keep asking questions. Always realize that you're never going to be sure about what you're doing. And I'm sure some excellent speakers later on will be talking about this. It's a constant state of confusion in science because you are doing things that no one else has done. So you should be confused and you should be perplexed at times, and that's perfectly fine. But the way to get around this is to ask yourself questions, but ask your mentor questions at the same time. And the mentor will be challenged tremendously, but the mentor is really appreciative of the student that keeps on going and keeps on questioning what's going on. It's the only way to prevent yourself from sort of misinforming yourself about the results or about how things are going. So you can question both how things are going from a technical point of view, but also from a relationship point of view. So never be afraid. And as Sam said, there are no stupid questions, but there are some stupid answers. Hopefully I won't be giving any stupid answers later, but I'll try my best. So here's a very important point, is one of the biggest issues with respect to this type of technical relationship is if you make a mistake or your boss makes a mistake, you've got to be honest about it. And this is one of the most important reasons about having this ongoing relationship, is that when I've had people in the lab who've made horrendous mistakes, I might put my head in my hands for 1 or 2 seconds. Then I think, okay, let's just fix it. Let's just get on with it. And that's it. And we just instantly brush it away. I'm happy that the students have said, I've made a mistake. If the mistake hasn't been owned up to, or I've made a mistake and I don't own up to it, it just concatenates and it keeps on going and grows and grows and grows. So it's, believe you me, if you're worried about doing something wrong, don't be. Your mentor will cherish the fact that you're being honest, and it's the only way to fix things and to move ahead in science. So don't worry if things go bad. That's normal. That's absolutely expected. It's one of the hardest things to take in science is the fact that it is a very low success rate. But that's why we have mentors, to keep you going. And clearly, the important thing there is to support one another, is that neither can do the job on their own. The mentor, if they have no students or they have no people working with them, they can't get anything done. And as a student, if you don't have a senior supervisor or someone informing you on how to push things forward, they're not going to get anything done. So you really are in each other's pocket. And that's the beauty of this whole process. Neither one is an island, and you cannot live like that. And that's why, as I said right at the top, this is the essence of what science is the mentoring relationship. And that's why you actually really, 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 really have to work at it. It doesn't come naturally, and you can start off being very compatible, and things can change, and it can get worse. But if you both have a common goal and a common desire, it will keep on working. So you really have to work actually as a team during this. So even if you feel very junior and you're new in the lab, your mentor needs you as much as you need him or her. So when things do go well, you really have to enjoy it. My goodness. And you have to make sure that any modicum of success that you experience, you have to really cherish it, because 2%, 3% success of your experiments and this process is going to be there. So you seriously have to, you really have to enjoy science, and you have to enjoy this relationship, and you can have tremendous fun in this respect. And you can end up not being like poor old Chewie, who didn't get a medal. But he got one in the end, so don't worry. So as we go forward, so this is what I mentioned at one of the earlier slides, was to have both short-term goals but also long-term goals. What your mentor dearly wants is for you to go forward into the future and do what they do. So don't be afraid to presume or have have a consciousness of your success in the future. You really should do that. You should plan for your success. So you should actually talk to your mentor about this. And your mentor will be very happy to hear you thinking about future plans. So don't be worried about doing this too early on. First day might be a bit too excessive, but a few months after that will be perfectly okay, because it's good. You have to have these long-term plans, and the mentor will be more than happy to help you with this process. So let's say you've been successful, and let's say you've done a postdoc or a PhD or whatever, and it's time to go. It's so important to stay in contact, and you really need to sort of understand that often this relationship has to continue, because they will continue to help and assist you, and you will actually grow with that too as well. So don't be afraid to it's not like a sign of, hanging on to the coattails and stuff. It's actually really important to maintain this. And as you saw from this academic tree before, we're all part of this process. None of us rule those trees. We're all in that together. So maintaining that contact is really, really important. So when you do leave, and your mentor will be most overjoyed to hear that you're probably interested in collaborating with them in the future. So start thinking about this before you might even leave, or think that you're ending this relationship. You're never going to end this relationship. It's going to stay there forever if you make a wise choice and if you work at it and you build on it. So while you're doing your work, think about how you could potentially collaborate in the future, because this is what we want to do. We want to continue, want to be greater than the sum of just one person. Science doesn't work like that. It's a group team activity, and that's how we should always think about it. So think about how you could help out in the future. I've spent so much time trying to pay back what my mentors have done for me and try and help and assist them. So this is one of the kernel features of this process. Then here's the sad thing when I have to tell students about this. You've got to do it all over again. So wake up, dust yourself off, do it again. But you're not just doing it again for you, that you have to potentially, as a person that leaves a lab or a research group, is the goal and the dream of your mentor. They feel fulfilled when they see you going and being a mentor for somebody else. Then that's almost like, wow, I've done it. I've done a successful job of helping the scientists grow and develop and do research. And now they are contributing to this tree of mentoring, going all the way back from Pythagoras all the way down to us here today. We're all part of that wonderful team that has changed the world for everyone in such a wonderful way. And that's really all down to this connection of this relationship. So you have to live, die, repeat, as we see. So, oddly enough, I've tried to talk about mentoring with all these rather interesting connections, and you can see that my personality is all based on the movies that I love and the TV that I watch, and I've always dreamt of just doing a presentation just with pictures, because I think pictures are the best way to encrypt simple phrases, and it's just such a beautiful way of representing who I am. So this is what I do when I interview new people. This is me, okay? This is me with all my personality. This is how I like it. Do you want to come on this journey with me? And you should always choose and think of someone that you want to go on this journey with, because it's a journey that'll never stop. And hopefully, it'll be mutually beneficial to both of you. So it's one of the important points from today. Ooh, this slide's gone a bit funny, but there you go. So I wanted to crunch these down. So these are 12 rules for your scientific life. So number 1, choose your mentor carefully. Number 2, find additional mentors, more than just one. Number 3, make feasible plans for your interactive relationship. Number 4, make sure that you give feedback both from them and from you. Number 5, always keep asking questions. Number 6, if you do something wrong, your mentor will desperately be happy that you told them. They won't be upset. They'll be happy that you're fixing the problem. Number 7, you are a team. They need you, you need them. Number 8, when you do get success, definitely celebrate it, because you really have to, because it won't come often. Number 9, you really have to discuss your future plans and think about them early on, because you want to grow together. You don't want to drift apart. Once you leave, important to always stay in contact and maintain your relationship. Number 11, try and collaborate in the future and be part of this academic tree. And number 12, the real measure of success and the ultimate output of this mentoring relationship is for you to go and repeat it and do it again. So I really hope that all of you out there can continue and proceed with this wonderful interaction between humans and science. I think it's the most important thing that we can do. So thank you so much for listening to me ramble on, hopefully not too long. So this is from me in the Receptor Biology Lab, and thank you so much for your attention, and I look forward to the questions. And once again, thanks to Hello Bio for organizing this fantastic conference.
Thank you so much, Stuart. That was a fantastic start to the conference. So just before we move on to the Q&A, take a screen grab of all of Stuart's contact details, or you can message Stuart in the event chat as well. Okay, so let's take these slides down. So we have one question for you, Stuart, from Sam. And Sam asks, is obtaining a mentor or finding a mentor a formal process, or is it perfectly acceptable for you to just rock up to a colleague and say, oh, hi, I really admire you. Can you be my mentor? And also, what do you do if they say no?
Oh, that's a great question. So my answer is do it informally. Is that I think it's much better. So as a mentor, you're always impressed and happy when somebody has the get up and go and the proactive nature of coming to talk to you and coming to see you. That instantly is a self-selecting process to go, goodness, they are interested in me and what I do, and they've got the chutzpah to come and talk to me about it. So that, I think, please always go informal. That's the most important thing. If someone says no, blimey, I've never experienced that yet. And I've never actually, if someone has approached me, I've never denied them that. But if they do, I wouldn't worry about it too much, because the truth is, if they say no to you, you don't want to be with them anyway. And it's sort of, so you will end up being in a mutually selective process. So if you do ask them, and so if you do want like an extended mentor relationship, so the other important thing is you might not need to say it. So having one of these external mentors, having like these additional mentors, it's just someone that you're talking to. You don't have to say, can you be my mentor on this? You can just talk to them and get advice from them. So mentoring can, you can meet a random person on like the subway somewhere and talk to them for a few minutes, and they might give you such a wonderful piece of advice or a bit of genius insight that can stay with you forever. So mentors can be like sort of micro mentors that you meet for a few minutes and say one thing, or they could be with you for the rest of your life. So perhaps if you're worried about rejection, just talk to them. And talking and getting consistent advice is good. If it's your primary mentor, then I feel happy in a way that you haven't ended up with the person that isn't interested in your welfare or isn't interested in your science or your personality or how you do things. It's a mutually selective process.
Excellent. Oh, Sam, you're muted.
Oh, hang on. Am I unmuted?
Yeah.
Yeah, sorry, I was just going to pop myself into the stream there to just say, so your advice then, Stuart, to anyone is just, if there's someone you think can really add value to your sort of role and everything, just go for it, even if they're a Nobel laureate, because obviously
absolutely it's this is the thing. Even though we look at all these wonderful, tremendously big scientists, they're still regular people. I know many Nobel laureates and stuff, and they're regular people. Don't be afraid. They're just like you, and they may have all the names and the titles and the letters after their name, but you're just as good, and you're just as important. And if you knock out all the other people in these big networks of science and stuff, it'll fall apart. those people don't hold it together. It's everyone that holds it together. And so often, these networks are maintained by the people that aren't big or don't have big names, but you're part of it. I think that's one of the most important things that I've thought about, is the importance of everyone. We do this in our science. I do a lot of bioinformatics, and you only see certain types of biology when you look at things at a huge level, and then you see the patterns and you see what's important, rather than just the individual superstars and stuff.
Yeah, no, I think that's really, really good to know. It's a long time since I've been in a lab, or since I was a PhD student. But yeah, the feelings that, that person you can't talk to because they're so, they've got so many letters after the name or whatever.
Mm-hmm.
But yeah, I think this kind of advice would have been of benefit to me, certainly. I did also want to apologise, Stuart. I didn't give you your introduction, so I didn't tell everyone here your very illustrious career today.
Well, that's actually perfectly fine, because I shouldn't be. I'm just a guy. I'm just a dude. That's it. So it's like you should be known by the dint of your work rather than all that. So actually, that's the perfect way of introducing. And if I'm boring or dull, then I'm boring or dull. Having the letters after my name doesn't make me smarter or more enigmatic. So I always tell people that. I often have students email me and say, "Oh, dear Professor, blah, blah, blah." So no, I'm just Stuart, and that's it. Please, we don't do that. And the humility, I think, is important, because even though you do get old and you rise up, you would, if you stand on formality, you distance yourself from these mentoring relationships, because people do get scared, and they won't tell you if they've done something wrong, which is a disaster, because if that happens, then I know it's going to happen. So I'm not surprised that you tell me, because I've, as a scientist, all you can do is make every single mistake once, and then hopefully not again. And that takes a few years. Once you've done that, you've made every mistake. But, I'm honest about it. Other people will say, "Oh, no, I never make mistakes." Like, no, I've made every mistake. And it's like, everyone is a great story. And it's often fun to tell these and stuff. So everyone will collect their stories of horror in the lab. So it's part of the process.
Can you ever have too many mentees, do you think, as a mentor?
It is a problem. It can be a problem. And that's actually, so the mega lab sort of way of, a lot of investigators, feel pride with having hundreds or 20s of mentees. And then the relationship does become very small and fractured. So the best way to get around that is to have some form of delegation, and actually realize and actually sort of spot amongst some of your more senior people who are the ones that attract the reliance and the interest of the other students. And you often find there's this thing of approachability, and it's tremendous. There are just some people that are tremendously approachable. I'm the complete opposite. I've got this sort of stony, dull face, unfortunately, which is not true, because I'm a very different person. But there are some people out there that are just approachable, and people just love them, and they instantly attract people. And those sort of people think, they're the sort of nexus of the lab. They're the ones that everyone goes to. So often you can sort of mentor by mentoring that person. So you have to see who is the sort of the linchpin of your lab, and who is the person that is actually the confidant of people there. Then you'll get to know a lot more about people. And it's a difficult process, because you don't want to be intrusive, and everyone has their own private lives and stuff. But there's a certain degree of understanding people that is outside of those things. But the understanding and appreciation is the most important thing to maintain. And often a lot of people don't do that. I think a lot of people are scared about this overstepping of boundaries. But this is sort of at a functional level. It's your boss should be there to help you function as a scientist more in a better way. And so that's often one of the things not a lot of people spend enough time on doing, is understanding the emotional requirements of science and the emotional requirements of work, and what makes people tick. So as a mentor, you have to sort of identify what makes people function best, and spend your time doing that. So being an observer is tremendously important. So you can't just focus on your own thing. You have to realize that actually your talent is just as important as the new big mass spectrometer you can buy. Because you have all the machines in the world, but if no one's working on them and everyone's staying at home, it doesn't work. So you have to work on the human value, and That's the importance of the relationship. And often people don't get educated about this. They don't think about it. I've spent my entire life thinking about these relationships because I realize that that's the important thing. Everything else is secondary.
Yeah, it's so true. And we've got time for one more question before we need to finish up and move on to the panel. So thank you so much, Sam, for jumping in on the discussion. That was so helpful. So we've got a question from James Flanagan in the Q&A, who's also on our Hello Bio team. Hi, James. And James asks, when do you think you can become a mentor? So does this happen professionally? Do you have to have all the letters after your name, as you say? Do you have to have a senior position, or is it just a call that you make in yourself if you feel like you're able to help and you're able to offer something?
Well, that's a great question, because actually I do actually some work for the University of Luxembourg, and we actually have instigated a new Special Mentors Award. And when we discuss the award of these things, we often realize that there are many different levels of mentoring, and there are people that are sort of mentors who are almost the peers of people who have received the actual mentoring advice. So the truth is, it's all based on experience, or experience of science perhaps, or also a personal experience. So as a mentor, you can be, if you can help, so this is the ultimate purpose of mentoring, is helping. If you can help somebody either with a technical issue or an emotional issue or a cognitive issue or an academic issue, if you can help, you're a mentor. So if you're a positive, helpful person, you are a mentor. You don't need to be lab boss or senior or blah, 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 blah. If you can help, you're a mentor.
I love that. That's brilliant. And I think that's going to lead so nicely into the talk on imposter syndrome we've got coming up later. So that's brilliant. So thank you so much, Stuart, for your time. Problems. Stuart will still be hanging around in the event. So if you do have any questions, you can ask him in the chat, and do check out the stage chat, because there's some great chats going on in there. One of our speakers from later, Joanne, is sharing lots of resources. So do definitely hang around and stay in that chat. So thank you so much, Stuart.
No problems.
So I'm going to hand back over to Sam now, who is going to introduce our first panel of the conference. Over to you, Sam.
Hi there. So we have got James Quinn, who is going to chair our writing, peer reviewing and publishing papers panel discussion. I'll just tell you a little bit about James, and then I think I'll hand over to James to introduce the panel members. So James is a neurology research fellow in the Alzheimer's Clinical and Alzheimer's Clinical and Translational Research Unit at Massachusetts General Hospital and Harvard Medical School, under the supervision of Dr. Becky Carlisle and Dr. Stephen Arnold. Dr. Quinn's research involves studying the neuronal signaling molecules, neuropeptides, in dementia pathogenesis to unravel disease mechanisms, identify new diagnostic markers, and define novel therapeutic targets. His PhD research at the University of Manchester focused on the role of tau proteolysis in dementia pathogenesis. James is passionate about community engagement and public outreach, and he also works to improve the landscape for early career researchers with the Alzheimer's Association. So I'm delighted to hand over to James, who will run the panel discussion.
Hi, Sam. So thank you very much for the lovely introduction there. I wish I had pulled together a really nice introduction from Bronwyn and Matthew, who are going to be the kind of experts on this panel. But I can add a little bit more introduction, about myself on this kind of topic. So I'm currently trying to write a paper right now. So I think this session will be equally as useful for me. I have started doing peer review. I only really started getting opportunities for peer review when I started my research fellowship, which is just our fancy terminology that we use for a postdoc here at Massachusetts General Hospital. And so I have like a little bit of experience. I've got a few publications, but definitely not as many as some of the other panelists that will be presenting today. So I'm delighted to be joined by Dr. Matthew Lloyd and Dr. Bronwyn Martin, who I'm sure can do a fantastic introduction of themselves that I do not have. So maybe we can start with you, Matthew.
Okay, thank you. So my name is Matthew Lloyd. I'm I work at the University of Bath, where I am a senior lecturer. That's the equivalent of a US associate professor. My background is chemistry and biochemistry, and I now work on fatty acids, enzymes using enzyme kinetics, chemical biology, and I'm interested in developing enzyme inhibitors as drugs, enzyme inhibitors as potential drugs.
Thank you, Matthew. So Bronwyn, would you like to go next?
Okay, well, thank you, James. It's great being here, and thank you also to Sam, Alice, and Hannah, and the Hello Bio team for putting on a really fun conference. I think everyone's been looking forward to it. So I work at the University of Antwerp. I'm a neuroendocrinologist by training, and I work in the Faculty of Pharmaceutical, Biomedical, and Veterinary Sciences, and I help our researchers with writing their grants and with their papers. And I also do a lot of the research communication for my faculty.
So that was fantastic. Thanks both for the little introduction. So we have a few questions that were we've already generated some answers on, but we're totally up for Q&A. So please, any questions that you may have. I have questions about publishing. I'm sure many of you in the audience will have questions about publishing. It's the one thing that we're told to do as academics. Whether it is the best means of getting our work out there is a different debate. But I think we can really focus on, the first question here. So what are your top 3 tips for writing great scientific papers? So maybe we can do, Matthew do one, Bronwyn do one, and we can kind of just go like that.
Okay. Yeah, top 3 tips. Think about who you want your audience to be, because that's going to determine which journal or other media you're going to publish in. Think about how you want your audience to use your publication, because clearly if you're writing a review, that's going to be used in a different way from an experimental paper, for example. And then finally, write a complete and compelling story. So those are my tips.
Yeah, you've hit every nail on there. So Bronwyn, would you like to go next?
So yeah, those are excellent tips, and I fully agree with Matthew on that. I think writing a compelling story, so having a very good structure to your paper, is very important. There's nothing worse than sort of having to read through a very muddled, confusing paper where the data isn't really sort of explained in a coherent manner. So how do you go about sort of creating good structure to your paper? The best way to do that is to really think about your data and how you're going to present your data, and to first get your data packaged into a coherent story. And then once you have your data packaged into a coherent story, then you can start the writing process. The second tip that I would add to that is, it's something that is often overlooked by people, is to think carefully about your title and your abstract. So search engines are used to access your paper. So most people will search for your paper on PubMed or on Google. And the search engine algorithms will look for specific keywords. And if those specific keywords aren't in your title or in your abstract, then your paper won't be found. And there's approximately, 34 million publications in PubMed at the moment. So it's important that you write your paper and that it will also be found by people so that they'll read it. So really be careful to think well about which keywords you add into your title and which keywords you add into your abstract. And then the third tip that I would add is in the discussion, really sort of try to have a nice summary where you sort of summarize the data and also try and offer an explanation for the data, or if there is no explanation, sort of try and sort of come up with alternative answers. So structure, think about the keywords in the title and in the abstract, and in the discussion have a nice summary and basically a take-home message for people reading your paper.
So I think they're really all really good points, and I'm just going to add a few things, mainly focused towards early career researchers, that I can think about that I've had to deal with over the last 5 years where I've been publishing. I think the first thing is I tell my students in the lab, get a Google Scholar account, get a ResearchGate account, get ORCID, get everything you can where your publications are going to go, right? Because that is the amount of people that read my publications just on ResearchGate, for example, they don't even see it on, when they go on PubMed. So, and the other thing would be Twitter as well, LinkedIn. People will click on your paper from those. I've seen people put publications on their email signature because they want to get every email they send, someone click on their paper, or even just linking to, your Google Scholar or ResearchGate. And keeping track of these things, because I'm currently applying to positions right now, and the amount of things that people look at your publication. So having it all already formatted is extremely helpful, and being able to access that and provide it to people who are interested is really helpful. So I think we can move on to the next question, and we can kind of go from there. So there is question number 2 is where can you get papers published as an early career scientist, and what's the best way to go about it? So Matthew or Bronwyn, whoever wants to take this one first can.
Perhaps Bronwyn, you'd like to start on this one?
Okay, so at the moment there are lots of different journals, so I think we're all sort of spoilt for choice, so that's nice. But it can also be overwhelming, because where do you start? So I think the first thing to do is, if you're an early career researcher, is to first talk to the people in your lab and to your PI and ask them, which journals do you typically publish this type of data in? Are there journals with which you've had good experiences, journals with which you've had bad experiences, where, for example, it took forever to peer review your paper, or the reviewer comments weren't particularly helpful? So first get feedback and advice from people around you in the lab, because they might already be able to offer you that advice. The second thing is to sort of find a good balance between the cost of the journal. Some journals are extremely expensive, which for early career researchers might not always be a good option. So ideally, you want to find a good balance between the cost, a high impact factor, and ideally also an open access journal, because I think publishing your data open access really helps with the visibility of your paper, because a lot more people will be able to access it. Another useful thing, I used to work at the National Institutes of Health in Bethesda in Maryland in the US, is often on our Bethesda main campus, we would have visitations or lectures from editors from journals. So people on the editorial team would come to our campus, and they would talk about the journal, they would talk about the review process, they would talk about the type of work that the journal was interested in. Go to these presentations, meet these editors, and start creating a network of people that you know, so that you know which would be good places where you can submit your work. And then the last tip that I would have is start creating a network early, because journals will always ask you, do you have a recommended reviewer? So if you can start making a network of people that you know and trust, then these also are potential people that could be a recommended reviewer, or that would be able to suggest someone as a recommended reviewer. So those are my tips. So on to Matthew.
Thank you. Yeah, so great advice. I think the thing I'd just like to add there is, obviously you're going to be reading research in your specialist area, and so just think about whether any of these journals that are publishing this research from other labs might be suitable for the research that you're doing.
Yeah, I think that's some really helpful advice. So I think I might add 2 extra points. I know in my PhD we had a journal club, and that was a great idea, a great way of finding out which journals were good for the sort of work that we were doing, because we were presenting work that's coming out in the field, and we were presenting that. And then I think the other thing would be obviously talking to your supervisor. I've heard of many horror stories where someone's been asked to publish a paper, the paper gets published and the supervisor doesn't know about it, or vice versa, right? So I think having a really good open line of communication with your supervisor is extremely important. You don't want to burn any bridges, especially with your supervising team. So just make sure everyone's on the same page, everyone's happy with the journal that you're going to submit to, and also don't be afraid to aim high. I've submitted many what they called like a pre-submission inquiry, which a lot of these kind of high impact journals have. many times I've been rejected. I think I've never actually got one into one of those high impact, the super high impact journals, the Nature's, the Cells, everything. But just the mere purpose of pulling together a very short 500 word summary of the article was extremely helpful in the kind of writing process, because it's definitely helpful to have a journal in mind before you start writing, because you can get the formatting established and make sure everyone's happy with that. So I think we can move on to the final question. I'm just going to reiterate to the people who are watching, if you have any questions, just add it into the comment section. So the final question, one I can also talk a little bit about, is how do you know when you're ready to start peer reviewing papers, and how do you get started? So maybe Matthew or Bronwyn, whoever wants to take this first.
Shall I go first? Yeah. Okay. So I think knowing when you're ready to start, you need to have built up a reasonable expertise in the techniques that you're using. So primarily when I review, I look at the way in which the experiments have been done. I'm not an expert in the absolute sort of specific subject area of the thing that I'm reviewing usually, but I will know about the techniques which have been used, and I can make a judgment about whether the experiments have been done correctly or not. And in terms of getting started, well, probably a good way of getting started is just to register as an author with various journals that you'd like to publish in, and make sure that you add the various sort of descriptions and keywords of what your expertise are, because I know one of the main ways in which journal editors find reviewers is they just look at their bank of authors.
And Bronwyn, would you like to add anything?
Yeah, so I think Matthew really sort of covered some important tips. I fully agree that you really have to make sure that you have enough expertise and knowledge of the actual experiments that were performed to be able to judge someone else's experiments. Because if you've never done those types of experiments, it's really difficult to really know if they've done the experiments appropriately. I started peer reviewing when I was a junior postdoc, and the way I did it was my PI was often invited to peer review papers. And then he would actually give the paper to me, and then I would do the peer review, and then I would give my peer review comments to him, and then he would go through it together with me, so I could see if there were things that I needed to do differently. For example, one thing that I find a lot of reviewers do is they're often too vague. They don't specifically state exactly what the author needs to do. They'll say, oh, it would be nice to do this experiment, but do you actually mean that we have to do that experiment, and under which conditions? And you have to be very specific of what you ask the authors. So I think it helps if you can find a senior person in the lab. It doesn't need to be your PI, but maybe a more senior postdoctoral fellow, for example, and see if for the first peer reviews, whether you can do them together, and then you can learn from a more senior person. Another way that I learned to do peer reviews was we did special issues of journals. So we did a special issue around a topic. Then we would invite authors to write and submit papers for their special issues. And then we would find peer reviewers for the special issue, and then myself and my PI as the co-editor of the special issue, we would then oversee the full peer review process. And then you can actually see different people's peer review styles. So that's actually very, very helpful to learn from yourself. So yeah, those are my tips.
And I can just add a few extra things. So it's becoming quite a new thing. I think journals now realizing not everyone, especially senior academics, have way too much on their plate to do tons of peer review. So a lot of these, journals, I even saw Nature Communications, they've just started a career. It's basically an early career reviewer panel. So essentially, you work with an editor to review a paper, and if that goes well, they then bring you in to do more. So you kind of pick a paper that's within your expertise. I've currently done this for, I think it's Alzheimer's research and therapy. So it falls very much within my remit of my research. So I was able to actually get my first peer review because I signed up to their Reviewer Academy, I think is what it's called. And then, you kind of click what you're interested in. And then I've also done that the same way Matthew was describing earlier of, signing up as an author for journals. I didn't realize you can do that even if you're not submitting a paper. So you can just literally just sign up as a person on that account, and then you can basically establish your author profile, and then people will then reach out to you for review. And I've also had a few people put me down as potential reviewers. Not all of them always come through. Sometimes I'll get a message saying, "Oh, do you think you could review this?" And I would say yes, and then I never actually get a message from the editor. So I think just having a bit of a presence is definitely helpful. Occasionally people will message me on Twitter or LinkedIn or send me an email and just ask whether, as they're an editor in a journal, whether I could, potentially peer review. And I have rejected a lot where I've just not had the skill set. I know some were like a meta-analysis, and I don't have that kind of statistical background. So I think, and there's definitely a line, sometimes you can also peer review. So for example, I recently did one about a big proteomics study, and I could review the techniques they used in the proteomics, but there was some aspects of the paper I couldn't really review. But because I was part of the early career Reviewer Academy, they said that's fine, just peer review the bit that you're kind of an expertise on, and then you can specify the area that you weren't able to completely peer review. So they had a statistician come in and look at this specific part of the paper, because I wasn't an expert there. So I think knowing your limitations, which Matthew was kind of describing before about the techniques, and that Matthew would peer review the techniques, but maybe not have a full understanding of the kind of the whole goal of the paper. So I think they were two areas that I kind of approached just to start peer reviewing, and obviously with what Bronwyn mentioned, I think they call it like ghost peer review now. I was always hesitant to do that because, especially to try and, for me trying to apply for a visa to stay in the US, for example, I have to show that I peer reviewed, and it gets difficult if you don't have the letters from the editor to say that you did it specifically. So I think there's a balance. If you want to do some just practicing, I think that's a great approach. But then if you want to get your name down as a peer reviewer, I think just starting to establish those relationships with your editor, and sometimes your supervisor can recommend you as the peer reviewer instead of it being them. So I think there's definitely a balance there. So we had a few questions from the audience, and the first one is from Joanne, to talk a little bit more about preprints and open publishing. It seems like the wave of the future. So maybe Bronwyn first, because correct me if I'm wrong, where you are, isn't everything has to be published in open access journals? I know some European countries, not the UK, are being very specific about everything has to be open access, but maybe you could talk a little bit about that.
So it depends on who your funding agency is. So if you get European funding, then it needs to be made open access. And also in Belgium, a recent copyright law has been passed that for the biomedical sciences, within 6 months, you need to make a version of your paper freely accessible, open access. So indeed, in Europe, we're sort of making big strides to make work more freely available for everyone. I think the preprint servers are very exciting, and I think they really sort of started to be used a lot during the corona pandemic. I think we saw a huge influx of thousands of papers being added to the preprint servers. And I think that was really sort of the turning point, in my opinion, for these preprint servers, where they really became more mainstream, that it became more of a common thing to put your paper first on a preprint server, like, for example, bioRxiv in the biomedical sciences. And there are actually more and more journals now that require you to first deposit your paper in a preprint server before you can submit the manuscript to them. I'm all for them. I think that they're a great step towards the future. I think it's also good because they'll help to have more of an open peer review process, which I also think is a significant step forward. So I would say if you can, there's nothing wrong with depositing your papers in a preprint server. I think it's an excellent way forward.
And Matthew, do you have any comments to add on that?
Yeah, so largely when we do open access publishing, the university at which I work, we have a kind of transformative agreements with various journals. So what that means is that when we subscribe, the university subscribes to the journal, then we can publish open access our own papers. And so because the journals which we're doing this for are very good journals for the type of research I want to publish, then I often will go for those journals anyway. So that's good. I have very limited experience of using preprint servers. I think generally speaking, that's very good. The one note of caution that I really want to add is just if you have a journal in mind that you're going to eventually publish your paper, just check the author guidelines to see what they say about pre-publication.
Yeah, I think I'd echo that. I think we recently published, and that journal had its own preprint server, if that makes sense. So it was very much like, we submitted to the journal, they published it open before we finished all of the review. So it was kind of like a halfway point, really. Whereas I don't think they would have permitted us to put it on, for example, bioRxiv, because they had their own system in place for having their own preprint server. So I think definitely it's beneficial, and I know a lot of funders, and I don't know specific. I know in the US and somewhat of what's happening in the UK, but there's definitely more of a push to say, okay, preprint is not the same as a publication, but it's very much on the way to being a publication, right? So a lot of funders would say, okay, you've got a preprint, that kind of ticks that box of having that publication. Maybe it's not a full, publication, but still it's showing that you're able to pull your work together in a format that can be accessible and can be reviewed by others in the field. And I think what the point Bronwyn made about COVID is it's kind of fascinating how much press preprints got. I think that was both a positive and a negative. You would see good preprints and you'd see bad preprints, and there was no real system in place to kind of vet those too early on. But I know, for example, medRxiv, which is the kind of more medical focused version of bioRxiv, they definitely introduce a few more steps that you have to kind of go through in order to get those things published. So we have another question. I think it was from Sam. And it says probably a topic for a whole other talk. But anyway, but what are your next steps if you get a paper rejected? So I don't know if Matthew or Bronwyn's had a recent paper rejection, but that would be a great place to start.
Would you like to start with this one, Bronwyn?
Okay, I'll start with this one. So yeah, I think we've all had papers rejected. I think it's quite a normal process. It depends a little bit for what reason it was rejected. Sometimes it's rejected, but if you contact the editor says yes, but with the necessary changes and this and that, we would still be interested in your paper. So sometimes it's worth contacting the editor and saying, look, we are very interested in publishing in this journal. If we make modifications, would you still consider it? If the editor says yes, then it's worth going on a process with that journal. If the editor says no, we're totally not interested, then of course you consider other steps. And like I said before, there are so many journals out there, then it's just a matter of finding another appropriate journal for your work. Sometimes what has happened in my case, for example, is we had one reviewer who was being very difficult and who was he wanted the paper rejected. We had written a review article, and the reviewer said, you need to reject this article because all they did was they reviewed other people's literature and they didn't put any of their own data in. And we were kind of, well, that's the whole purpose of a review article. And in that case, we did have a lengthy discussion with the editor-in-chief of the journal, where we said, look, we would like to bring on additional reviewers because clearly this reviewer might not be the most appropriate person. And then an additional reviewer was brought on, and then our paper was actually accepted with minor modifications. So sometimes it helps to really sort of contact the editor and go in conversation with the editor and see, can we sort of get our paper into this journal? Or if the editor makes it very clear, no, it's not within our scope, we're totally not interested, then just cut your losses and find another journal.
And Matthew, any additional comments on that?
Yeah, so I've had this happen quite a few occasions. So generally speaking, if I get a paper rejected, or even if it comes back with major revisions, then I will contact the editor and ask for further clarification. It really depends on the circumstances. So, for example, about 10 years ago, I had a paper where the reviewer clearly hadn't read the paper properly. And they said, you need to do experiments X, Y, and Z. And we'd already done the experiments. And I wrote back to the editor and I said, look, you've rejected the paper based on the reviewer. The reviewer has clearly not read the paper properly because we've already done it. The editor then allowed us to resubmit the paper, but we then got another reviewer who didn't understand the paper. And at this point, we kind of thought, well, really, if the reviewers are not understanding it, we're probably sending it to the wrong journal. And so we submitted and published with a different journal instead. On the other hand, so I had a review article relatively recently, so this was in 2020, where I got okay reviews from the reviewers, but the editor expressed some concerns, and I had an extended conversation which was very helpful with the editor, and we eventually ended up rewriting the paper, and it was published nearly a year after the original submission. So the editor was extremely helpful in this particular case.
So I think I'll just add a few final points there. So I think what both Bronwyn and Matthew said was incredibly important, and the points I took home from that was, don't be afraid to contact the editor, whether it comes from the first author or the last author. I don't know how much difference it would make, but generally probably makes sense to come from the last author because they're slightly more senior, especially focused towards early career researchers. And I think the point that I also took home from that from Bronwyn and Matthew is that rejection is normal. It's extremely normal in academia. You kind of become hopefully slightly immune to it as time goes on, but it's just a normal part of what we do. It's extremely competitive, and there is way more publications that can be potentially submitted. So don't be afraid, to start high and kind of expect rejection. And if you get in, great. If you don't, kind of set your goals a little bit lower. And then really focus on just getting that great story out there, getting that publication out there, and hopefully not having to deal with rejection, even if it does mean having to either negotiate a little bit with the editor or think about where you're going to resubmit to, or even if it means doing review. I don't think I've heard any single early career researcher I've ever met saying they got a publication in one go. I've ever met anyone who's had that happen. So I don't know if Matthew or Bronwyn has, but yeah, very, very rarely have I ever heard of that. I don't think I can even think of an example. So I think it's just very normal to expect there to be some kind of discussion about the publication from the reviewers, and all of these things are going to need a little bit of work. And these things take time, but you'll definitely get there. So firstly, I'd like to thank everyone in the audience. I can't see your faces, but I assume you're lovely people, and I really appreciate you watching this, and obviously really appreciate both Bronwyn and Matthew for kind of getting involved in this panel and providing your expert input, and obviously to Sam, to Alice, and all the countless people behind the scenes at Hello Bio. Hello Bio have been very supportive of me in my career, so I really appreciate that. And thank you for Hello Bio to putting on this event. So I think Alice is back now. So Alice, take it away.
Thank you so much, James, Bronwyn and Matthew. That was absolutely fantastic. So we are going to go for a short break now. So you can all grab a drink, stretch your legs, and we will be back at 2:30 with Dr. Matthew Cayley, who is talking about failure, resiliency, and overcoming imposter syndrome. So stay tuned, and we will see you in 11 minutes. Thank you so much, everyone.
Hi there. Next up, I'm delighted to introduce Matthew. Dr. Matthew Cayley is a skin researcher and lecturer at Queen Mary University of London in the UK. He received his PhD in biological sciences from Cardiff University in 2008, studying chronic wounds under the supervision of Professor Phil Stevens. He then moved to Imperial College London, joining the laboratory of Dr. Justin Sturge and Professor Jonathan Waxman to study prostate cancer metastasis and the role of the extracellular matrix plays in controlling cell behaviour. In 2011, he moved to the Blizzard Institute, returning to skin research in the lab of Professor Adele O'Toole. In 2019, Matthew was appointed as a lecturer in cell biology. His lab focuses on the skin basement membrane and investigates its role in healthy and damaged skin, in skin aging, and in skin cancer. So Matthew will speak on the subject of failure, resilience, and imposter syndrome in a fascinating talk in which he'll share his own experiences, obstacles, and how he overcame them. Thanks so much for sharing with us, Matthew. Over to you.
Thank you very much. Really kind introduction. Hopefully you can see my slides now. You shared those as well? Excellent. So I'm going to talk about failure, resiliency, and overcoming imposter syndrome. I feel I'm completely inadequately skilled to do this, which is probably appropriate for talking about imposter syndrome. I've got a conflict of interest. I worked as a paid consultant for Unilever. That has absolutely nothing to do with what I'm talking about today, but it's the first time I've had a conflict of interest, so I'm very excited to be able to announce it. So I'm a lecturer in cell biology. I have a small research group. I do quite a lot of teaching. I'm a module lead for an MSc in regenerative medicine. I'm also a founder member of Skin Microbiome and Healthy Aging, SMIHA, as a research network funded by the UKRI. So I work on skin research. I'm fascinated by the skin basement membrane and how it has a diverse range of functions in controlling the skin. I look at genetic skin diseases, specifically epidermolysis bullosa. I look at skin cancer, mostly squamous cell carcinoma, and I look at skin aging. I do this with charitable grants, with research council funding, with industry funding, and industry collaborations. So I'm going to talk to you today about failure. As we heard in the last session around publications, most of your publications, if you submit them, that will be rejected. But in research, people don't talk about this. We talk on our Twitter accounts, and I'm guilty of this. We post our latest, greatest paper. We post our greatest grant, latest grant, but we don't talk about all the many, many papers that got rejected, or the many, many times a paper's been rejected. And we don't talk about all the grants that didn't get funded. So this gives sort of an artificial sensation of sort of success to people sort of coming into the field, and especially junior colleagues. I still consider myself to be very junior in the field. So in research, failure is almost built in. Looking at the published success rates for grants, this is an interesting exercise and slightly depressing. These are the success rate for grants that have already got through the sort of triage phases. So these are top quality grants that have gone through to the final phase. At Wellcome Trust, about 90% of grants that get through to this phase will get rejected. Across all the UK are either the government-funded research organisations, 80% will get rejected. In the areas I am working in biological and in medical research, we're talking between 70 and 80% of all grants get rejected. It's the same when we try and publish things. So looking at some of the top journals, Nature rejects 93 and a bit percent of the 92 and a bit percent of the papers that get submitted to it. Science rejects even more. Even wonderful open access journals like PLOS ONE, who have a much more open approach to publishing, still reject more than half of the papers that get submitted to them. So if failure is sort of built into research, should we really be talking about it as being failure? I like the idea that it's not really failure, it's feedback. And on that sort of note, I'm going to use a quote from Dr. Abdul Kalam, the 11th president of India, who knew a fair bit about succeeding and about failures along the way. He suggests that you shouldn't read success stories. You only get a message. If you read failure stories, you'll get an idea of how to get success. So on that theme, I'm going to talk to you about how I ended up where I am now as a lecturer in cell biology. I'm going to talk about the successes I've had along the way and the failures. And throughout this, there's a topic about resiliency. So resiliency is an interesting idea. It means the capacity to recover quickly from difficulties. It's synonymous with toughness. But if you go into material sciences, it's also synonymous with elasticity. So the ability to be able to bounce back from failure or from setbacks. And definitely throughout my career, being able to be resilient, to be able to bounce back has been incredibly important in terms of being able to continue doing what I love, which is science and the teaching of new interested minds in my field. So please don't tell any of my colleagues, but I didn't always want to be a skin researcher. Obviously, I wanted to be a pirate as a small child, and my first steps into the research labs were in the Hoffman lab in Edinburgh, looking at crystal structures of proteins, and then going to York, looking at developmental biology, and at AstraZeneca as a master's student, looking at NMR structures of proteins. And along the way, I suffered my first failures. As a 6-year-old, I couldn't grow a beard, and you can't be a pirate without a beard. And in projects I did at Edinburgh, at York, and at AstraZeneca, I failed to secure funding for a PhD position. We were interviewed, we got quite far, but they weren't able to succeed to get funding for me. So I was left sort of, again, looking for something else to do after these setbacks. So I looked in different fields, and I looked into skin, and I found a PhD that was really interesting, looking at chronic wounding. This took me to Cardiff, introduced me to Professor Phil Stevens, who has been a great sort of mentor and support through my continuing career. I learned about cell biology, I learned about extracellular matrix, both are things that I still work on today. I presented posters, still couldn't grow a beard, and had some amazing experiences. I got my first independent grant, a few £1,000s to go and visit the Babraham Institute in Cambridge. We put in more grants. We wanted me to continue working in Cardiff and continuing as a postdoc. By this point, I'd managed to grow a beard and was looking decidedly more piratey. So we applied for a postdoc fund, looking at how skin recruits cells into it. This wasn't successful, so I started looking around again for another job. I had this idea in my head that the computer's frozen. That there was problems getting funding in wound healing, and all the funding I saw was going into cancer. So I looked around and I found a wonderful position at Imperial College, working with Justin Sturgeon and Jonathan Waxman, looking at prostate cancer metastasis. So how prostate cancer spreads through the body and how it ultimately sadly kills the patients. I started doing work on 3D models. I presented my work all over the world, slightly more relaxed with my presentation style at this point. I also got married. So life goes on, even though you maybe aren't quite exactly where you want it to be. During my time there, I applied for over £500,000 worth of grant funding in fellowships, in direct grants to me, some of which almost got funded. We were still ranked 10th from over 100 grants, and they funded the top 9. Properly disappointing, but it left me again looking for a job, looking for something else to do. One of the problems of my entire time at Imperial was trying to get prostate cancer samples. Apparently, it's really hard to get men to give you samples of their healthy prostate. I can't imagine why. So I moved back into skin. Skin was much easier to get samples for, and I found an amazing project looking at the skin basement membrane with Professor Adele O'Toole here at Queen Mary University. She took me in as a postdoc. This was over 10 years ago. I continued working for her as a postdoc, and she allowed me to start applying for my own funding and supported that. So I was able to apply for grants, apply for fellowships, apply for research grants. I also had 2 children in the time I've been here. Again, life goes on, and it's important that you don't allow things in your life to sort of stop just because you're not quite where you want to be in your career. So I applied for fellowships, I applied for research grants, I applied for lectureships. All of these were unsuccessful until I got my first grant. The British Skin Foundation gave me almost £90,000, which I used to hire my first postdoc, Dr. Larry Jones. Larry's still with me in my lab 5 years on, and she's just been awarded her own first independent grant. So I've been able to sort of pass on and pass forward some of the support I got. I still wasn't doing what I wanted to be doing, which was running my own research group. And another sort of point, another thought is that there's not always the perfect job. The perfect job doesn't exist. Good jobs can pop up. And an opportunity arose for me to become a teaching lecturer or a part-time teaching lecturer at Queen Mary. So they have these posts, they only do teaching, they're not research active. And they agreed that I would spend half my time being a lecturer, doing teaching, and half my time still being classed as a postdoc doing research. Wasn't ideal, wasn't great. But it did allow me to start calling myself a lecturer, which helped in the grant applications, gave me some level of stability. I applied for, again, hundreds of thousands of pounds worth of grants to these funding bodies, all of which were unsuccessful. I did have some funding success. I got almost £500,000 worth of funding, which allowed me, even though I wasn't supposed to be doing research, to start growing my research group. And last year in September, I was able to apply for a full-time teaching lectureship. So using the experience I gained as a part-time lecturer, translating that into a full-time position. A little bit, again, around resilience and around sticking with things. I got the contract for this position 45 minutes before I would have been made redundant from my existing contracts. And again, I've applied for funding, and in the last 9 months, I've applied for about £750,000 worth of funding, and I've successfully received about £500,000 of research funding, while also getting multiple rejections along the way. So I've talked about sort of my failures, resilience, the fact that you keep on getting up, keep on going, keep on finding the new thing, things that have helped me along the way. We were hearing in the first session about mentors. So I have a number of different mentors who each give me different different parts of their expertise in teaching, in research, in management. I cherish my mentors. They're the reason I'm here. I do a lot of networking. I have had grants because I've networked. I've got onto boards because I've networked. I like talking to people and talking about my research. It's massively important, as is peer support and supporting your peers. So I try and help as much as I can, my junior colleagues, my staff who are working for me, and anyone who needs help. I spend a lot of my time helping other people, and I usually get that help back. I sort of meandered in my career from different aspects, different areas of research. This wasn't necessarily my plan A, sitting here working on skin. So have a plan B, a plan C, and a plan D, and be resilient. If this is what you want to do, just pick yourself up and stick with it. But remember, don't be afraid to ask for help. The last part of this talk is about imposter syndrome. So this is the feeling that despite objective success, people suffer from a persistent self-doubt, a fear of being exposed as a fraud or imposter. Some papers at the bottom. This was first described in 1978. Recent studies suggest that depending on how you interpret imposter syndrome, up to 82% of academics may have imposter syndrome or feel they're in some way have self-doubt about or are a fraud in their positions. This is even higher amongst minority groups, whether those be ethnic minority groups or LGBTQ plus groups. It can also be clinically associated with depression, anxiety, and ironically impaired job performance. So imposter syndrome is a huge thing, and it's sort of very hard to, in a couple of minutes, to sort of suggest ways of fixing it. There are suggestions for ways of managing imposter syndrome. There's loads of blogs and articles and things out there to give the same suggestions. These sort of barrel down to remembering that if the stats are right, most of the people who are around you will be also have imposter syndrome. So talk with others, listen to their feedback, listen to how they're doing. I presented this sort of talk at a conference. An amazingly successful professor running a large research institute came up to me and said that she had horrendous imposter syndrome and always feels like she's a fraud. She's the most successful person, but still feels that she's not doing it. So you're not alone. Talk with others and listen to their feedback. Look at yourself objectively. If you're in a job, you are hired based on your abilities. You haven't been fired yet, and that's probably because you're good at what you do. Resist the urge to compare yourself to others. Other people are always going to be doing better than you or more exciting things. That doesn't matter. What are you doing? What are you doing well? This is a conversation I have with my students quite often. Focus on how your task is progressing, not on how perfect it is. So progress rather than perfection. You're never going to have something that's absolutely perfect. You can have something that's going really, really well. And remember, celebrate your successes. Keep a happy file. If people are giving you nice feedback, if people have said good things, note it down, jot it down, keep it in a file. So if you're feeling low, if you're feeling down, you can look at it and try and use that to objectively look at yourself. And if you are feeling some of the linked things, the depression, the anxiety, and you're feeling this is getting down on you, ask for help, please. I know my university has anonymous counselling services that are available for students and staff. So take advantage of what's being offered. Don't sort of suffer in silence. So coming to the end of my 15 minutes, I've been resilient. I've bounced through my work because of the people who've been supporting me. These are some of the people I've missed, probably dozens of, who've helped me through my career, through my time, and have helped me be resilient. So thank you to them. Thank you to you for listening. If you want to contact me, here's my email, my Twitter. If you're interested in skin microbiome and how it's altered in healthy aging, scan this QR code and join our network to get interesting emails about this. Thank you so much for your time, and I'm really happy to answer questions.
Thank you so much, Matthew. That was brilliant. So I will ask some questions in the Q&A. So we have one question from Jasmine Benjamin, who's hosting our next panel. And Jasmine asks, do you have any mantras or anything that you say to yourself when imposter syndrome starts to arise?
I don't, and I probably should do. Yeah, one of the people I had on my big list to say thank you is my wife. And I talk to her a lot about what's going on, how I'm feeling. And she does with me. She's an incredibly successful genetic counsellor, is amazing in her own field, and also feels that she's a fraud and isn't doing very well. So we both basically talk to each other and tell each other off for being silly and not seeing objectively how good we are. But I should probably try and work out a mantra or something to sort of say to myself myself in the mirror in the morning, rather than which is my normal sort of mirror response. Normally 6 a.m. and I've just been jumped on by a small human because I was looking comfortable.
And I was going to ask something along similar lines, where, you know, we are all told a lot throughout our careers that it's important to celebrate our successes. So what are some ways that you celebrate your successes? I
like going to the pub, and I like taking people with me and buying them beer or wine or fruit-based alternatives depending on their choice. So we have a lovely pub around the corner from the institute, and that will be where people will be if they've had a big grant, if they've had a good paper accepted. You go out, you talk to people, you chat about your successes, and you share the love. And thank people who've helped you to get there, because if you have been successful, it's very rarely been because you've done something by yourself amazingly. It's usually you've done something being supported by our imaging facility managers, being supported by our administrators, being supported by your colleagues who've helped you put the data together. So yeah, I like to do that. We also go out for take my lab group out for lunch. We'll do dinners. We're trying to plan a summer event which may or may not involve axe throwing later in the year, just to sort of celebrate that we've had a good year. We've made it through. The lab's another year older, and we're still doing well. So yeah, social things are sort of my go-to, because it's nice to be able to do that.
Yeah, and that strengthens teamwork and sense of community as well. So that's always a great thing to do. So we have another question from one of our attendees. I'm so sorry if I mispronounce your name. I'm going so Rushikane O'Neill, and they ask, how do you find a genuine mentor? And when you do, how do you set the right boundaries? Like, how do you know when to ask them for help and when it should be stuff that you can do on your own?
So the mentors I've got, they've developed sort of organically. I was talking earlier today about a mentor I had when I was finishing my PhD, Vera, who she nothing to do with looking after me as a PhD student. She's in my department. I just chatted to her and we got on, and I sort of asked her for advice about things, and she looked at my CV, shouted at me in a way that only a German could, and told me to stop being so English and stop putting myself down and being self-deprecating. And I think she's solely responsible for me getting my first job. So the best mentors I've had have happened naturally, and they've always been, as been discussed earlier, they've always been sort of open to coming and chatting. I like sort of informal mentor-mentee discussions where you're chatting maybe over a coffee or just in the corridor about how things are going and that sort of thing. So you found a good mentor when there's someone that you're comfortable chatting to and can give you good advice, and if they are a good mentor, then they should hopefully be open to talk to you when you need them. So and sort of find the time for you. So yeah, that's sort of, I'm thinking about my experience, but that's sort of my sort of thoughts on the mentors I have and my interactions with them. Occasionally it's done over wine or beer, but usually it's a high-speed coffee as if we're both dashing off into different directions.
Brilliant. And we've got someone in the Q&A has just asked if you could share your email address again, Matthew, in the main event chat, because she missed it on the end of your presentation.
I don't think I'm in the main event chat. I'm just in the private chat at the moment, but you're perfectly well. So it's m_caley@qmul.ac.uk. I am semi-Googleable. There's another Matthew Caley out there who's a poet. If you get into a sort of page with poetry, then you've gone the wrong way.
Brilliant. I will make sure that Lucy gets your email address. And we've got one more question from Sam, actually, before we wrap up and move on to our next panel. And Sam asks, does writing down your successes and failures help in a cathartic way, like for a presentation like this?
Yes, is the short answer to that. Because sitting down, you think a lot about what again, talk about the grants, think about a lot about the grants you've got, because they're the ones that you're running, you're spending, but you can also see the amount. It's often easy to forget the amount of hard work you've done into things that haven't been successful. So it's interesting. It's nice to be able to see that where your time's been spent. It's somewhat frustrating, but it is very good to be able to do that, and to sort of look back at take the time to look back at what you have done, where the high points are, and just remember that I've been remembering a lot about the people who've helped me get here, as I've been trying to put them down. The people who taught me, June, who taught me how to do tissue culture, the first people who looked at my first ever research presentation back when I was in Edinburgh, those sort of things. So it's nice being able to remember the people who've helped you along the way, and the good bits, even though there's obviously lots of, I still don't like failure, but lots of failures and lots of things that haven't worked along the way.
Yeah, brilliant. And we've just had one final question come in, and we do have time, so I'll ask this quickly before we wrap up. So James Flanagan has asked in the Q&A, are you particularly proud of any of the times that you've been able to help and encourage people through difficulties or overcome failures?
Hugely. So I'm massively proud of my postdoc Hilary getting her first independent research funding. That's sort of made my day. But I have students who I mentored who did MScs through the lab, who have gone on and done PhDs and are doing amazing things. And it just makes me happy seeing and trying to keep in touch with everyone who's sort of gone through the lab and done great things. So yeah, I'm incredibly proud of a lot of my students and the postdocs who've worked sort of with me and for me, and the amazing things that they do, and I sort of bask in their glory. It's their hard work, but it's also, I hope I've helped in a little way.
Brilliant. Thank you so much. And Matthew, are you able to join the event after this talk to maybe have a chat and answer any questions, or do you need to head off?
No, I should be able to join in.
Amazing.
So, go over to the main chat and sort of try and sit in there and talk. Super.
Yeah. Brilliant. I will make sure that you get in there. Thank you so much again, Dr. Matthew Cayley. Okay, we are going to now move on to our second panel, hosted by Jasmine Benjamin. So I am going to hand straight over to Jasmine to introduce herself and our panelists. Over to you, Jasmine.
Thanks, Alice. Good morning, everyone. Hopefully everyone can hear me okay. My name is Jasmine Benjamin. I am a PhD candidate here at the University of Birmingham in Alabama, not the UK. I'm really excited to be here today. My work is focused on the effects of circadian disruption on risk factors for cardiovascular disease. And I'm also a graduate student, of course, so learning about how to write a successful funding application is really important to me right now at this point in my career, especially moving forward into a postdoctoral position in the next year. I'd like to welcome our panelists as well and give them a couple opportunities to introduce themselves. We have 3 fantastic panelists this morning. Morning for me, afternoon for you all in Britain, I suppose. So I will pass it on to our panelists. Whoever wants to introduce themselves first is perfectly fine. Just please introduce yourself and your work and your experience with the topic of writing a successful funding application.
Maybe I can start.
Sure.
So hi, my name is Patricia Maciel, and I'm an associate professor at the School of Medicine at the University of Minho. This is in a city in the north of Portugal called Braga. So I teach biochemistry and I teach genetics, and I also am a researcher at the Associated Institute, basically in neurogenetics. So I lead a team of approximately, it varies a little bit, between 20, 25 people. And so I've graduated in 1998. My PhD was in 1998, and a short time after I started my own group. And I have, even though I'm in Portugal, and Portugal is not, let's say, very rich in terms of research funding, we're not, so it's kind of limited in that way. But I've always been lucky to be able to find funding in different, actually not only national, but also international funding. Small, big grants, a combination of things. And so that's my experience that I hopefully I can share today.
Fantastic. Thank you. Dr. Bafour, Dr. Martin, whoever would like to go next.
Okay, I'll go, if that's okay.
Yep.
Yeah, hi, everyone. I'm Tome Bafour. I'm a reproductive scientist, and I've had a very interesting career journey, as you'll see from my profile that was posted by Hello Bio. So I'm just going to say right now, I'm a postdoctoral fellow at the National Cancer Institute at the NIH in Maryland, and I'm working mainly on autoimmune reproductive failure, or rather reproductive failure in the context of autoimmunity and cancer. And it's been a very interesting journey so far. Of course, to get here, I've had to write lots and lots of grants, and I'll be happy to chat with people afterwards about my failures. Like Matt said, I was actually very, 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 I align, a lot with what Matt said, which is, discussing your failures, to get ideas about, being successful later on. So great to be here. Thank you.
Dr. Martin.
Well, hi, everyone. I'm Bronwyn Martin. First of all, thanks, Jasmine, for chairing the panel. That's great that you're doing that. I work at the University of Antwerp. I help our researchers with writing grants and writing their papers. I also do the science communication. So I have extensive knowledge with writing grants, both my own, because before this I used to work at the National Institutes of Health in Baltimore, Maryland, in the US, where I was investigating aging, metabolic function and aging. And then here in Belgium, I've grown more accustomed with the grant process in Europe, which does have some slight differences with the US. So I sort of have experience of both now. And I look forward to joining you on this panel and discussing what it takes to write a good grant proposal.
Fantastic. Thank you. It seems like we have an international panel here, so we'll be able to get a lot of different inputs on all the different funding mechanisms that exist, whether it's in the United States or across the pond as well. We have a couple of pre-populated questions, so I'd like to make sure that each of the three of our panelists gets a chance to kind of weigh in on each of the questions. But in the meantime, if you all in the audience have any questions, please feel free to drop them in the Q&A section, and we'll be sure to mark off some time so that we can get questions answered as well. So for our first question, and then you all can answer in whatever order you'd like, but in your experience, what makes the difference between a successful and unsuccessful funding application?
Okay, I'll start. So to be honest, that is a very it's a much more complicated response than it seems, right? So in my experience at least. So but I'm just gonna share like the general from my experience what I think makes the difference, because I've been, should I say, fortunate or unfortunate to be on all spheres of grant writing. So from applying, writing and applying for a grant and getting rejected, and also being successful for a grant, as well as being on the section where I review, I'm a reviewer for grant applications. So I've been in all spectrums, and it's in all parts of the spectrum. It's very interesting. So what I would say first of all is, one of the things that would differentiate a successful and a non-successful application is that successful application shows enthusiasm, there's passion, jumping out from whatever the application is about, and also being able to convince your reviewer that what you're going for, what you're applying for, is necessary. So you're put in everything you've got to make sure you're able to convince the reviewer, who may not be in your field, so that I think, stands out. So it's like an ad, when you think of an ad that, should I say, compels you to buy a product, for instance, that's kind of how it is, so that successful grant has been able to convince whoever the reviewers are that your application deserves to be funded, whatever spheres they're looking at it from. So it could be something for international projects. It could be something for conferences, attending conferences, however little or small. You want to be able to convince whoever is reading it that this is necessary and should be supported and funded. So to me, that's one of the many things that I think defines a successful application from a non-successful one.
Absolutely. Yeah, I submitted in a grant last year in September. That was the first thing I was told, is to write it as if you're trying to sell your project as a product to the review committee. I think that's a really good way to think about it. Dr. Maciel, do you have any thoughts on the question?
Yes. So I agree with these concepts. Also, I think it's important to define your idea, your research question, and in a very clear manner and focused manner. So that's, I think, one of the problems that I sometimes find in grants that I'm evaluating. this going in multiple directions. So I think being focused and clear is quite important. I think innovation, the feeling of novelty that your work is bringing, either in terms of the concept or the methodological approach, how you are addressing the question. So people like to see that something is, moving forward, really forward in a fast way with your project. And I think then there's several points that are important that show your expertise on the theme, and that there's on the theme and on the implementation, let's say, of your idea. So for instance, to have of course the research team, the experience that you have, but even things like the well done budget show that you are aware of what you are going to be doing. Good contingency planning, so you predict that there may be problems with this and this and that, because if you are very all positive, it also shows that you're not aware of what is really the reality. And of course, I think it's, for me, two things that help a lot, and I, in my experience, have helped a lot, is to have preliminary data, of course, when you are able to get other sources of funding to prepare to have previous findings, and a good visual abstract, a good scheme visually, in the sense of this selling of the idea. For me, a good scheme can save a project, in my perspective. And actually, it helps you also think about it, because when you are preparing the scheme, you are organizing your idea. So in both ways.
Absolutely. Yeah, those schemes are incredibly useful, even when you're talking about publications. Someone who sometimes isn't in the field, it's good to be able to look at kind of a picture and be able to visually conceptualize how a project's coming together. And I can imagine that would also be extremely useful for a review committee for a publication or a funding application as well. Dr. Martin, do you have anything to add?
Yeah, I agree with all these suggestions. I think that they're excellent. I agree with clearly defining the problem that you're wanting to tackle in your grant, and then offering a potential solution. Often when I read grants from other researchers, I first have to read through 1 or 2 pages of just like general background information before I actually see what it is that they're trying to do in the grant. And I think really at the beginning of your grant, you just need to have a couple of sentences where you very clearly define, this is the problem that we're trying to solve, and this is how we go about doing it. Another thing that is important as well, and that often grant funding committees will look at, although it depends a little bit on the type of grant, is they will look at the expertise of the PI, of the person that is applying for funding. So keep that in mind, and really, as you progress through your career, try and build up as much expertise and knowledge. If you're an undergraduate, try and do internships, because if you've done a couple of summer internships, for example, and then you're applying for a PhD fellowship to do a PhD, those summer internships could help you to get the PhD fellowship. So also think about sort of your career progression and how you can sell your own skills and your own knowledge as a PI, besides just what is also in the grant. I agree, sort of having some preliminary data, if you're able to do that. Having mitigation strategies, so being honest and saying, these are some of the things that could go wrong, but don't worry, we've thought about that, and this is how we would overcome that. And be realistic as well. I think one mistake that people often make is that they are too ambitious, and that they try to do too much, and then you will see the reviewers say, but they're trying to do too much. So it's best to really sort of define a couple of very specific goals, and to really sort of try and accomplish those goals and not promise the world. So be very, very specific in what you say you can do. Yeah, that's what I would add to these suggestions.
Yeah, Dr. Buford, do you have anything to add to that?
Yes. So just to add to all the brilliant suggestions as well, is clarity. I think we need to, you need to be really clear and avoid making vague, sweeping statements. The reviewer wants to know that you've thought through, every process, everything you're putting in, because some of them actually know. Some of them know, when you write some methodologies and everything that you've done, or some of your potential pitfalls or expected outcomes, and they're like, this isn't, quite right. So some of them do actually know, because some of them are in the field and they know. So make sure to think through. So be clear about what you want to write. Avoid vague statements and be granular as much as possible. Of course, relevant details, not, try to also put in, what's relevant, and make sure to have thought through it all. I think that's what some reviewers also want to see, that you've really given time and thought to what you want to do as well. So that easily comes across when you're reading grant proposals.
Absolutely. Go ahead, Dr. Maciel.
Maybe just one additional idea, that is to try to fit your proposal to what is the call. So read very well what's the call for application. So what's the scope of the funding agency? What's their mission? What do they want? And that, I think, can make a lot of difference to adapt, because there's different things that you want to do, but you adapt your proposal to that funding body, which is has a plan, a goal, a purpose. So that's, I think, important.
Absolutely. Yeah, that's incredibly important. I know here in the United States, we have, the NIH, we have the NCLBI, we have so many different funding organizations that then have kind of subgroups for different funding opportunities. So it's really important to look at the call for applications and make sure that you're able to tailor your application to whatever it is that they're asking for. I also want to just touch on what Dr. Martin said about making sure that you have a level of expertise. For a lot of us as graduate students, we're kind of developing our expertise, but it's really important that you're able to, if your lab is not particularly well versed in a specific technique, maybe pull another PI onto your mentoring team who is an expert in that technique, and that can also go a really long way in showing that you have the initiative to find someone who has that expertise and can help you, but B, also strengthening your application by demonstrating to the review committee that you have the ability and the needs to be able to actually do whatever techniques it is that you're proposing. So thank you all for your answers to that question. We'll shift gears a little bit here, and let's say that you submit a funding application and it gets rejected. I'm sure we're all familiar with that here. What are your next steps after you find out that your application has been rejected?
I can start maybe. So I analyze, of course, the criticisms of the people who reviewed the grant and see if I agree. Often I do. Often I think they have a point, and so try to revise your project, improve it according to those suggestions. Also, meanwhile, probably you also matured your idea a bit further. And also perhaps sometimes not necessarily change the project itself, but the way you're communicating, because something was not clear. So that's why they didn't understand it. A bit like in the papers, I guess. You try to, and try again. So basically we all fail, and then try. So I do this very often, try resubmit a revised version. I think this part of the funding agency is also important. Maybe your idea was not submitted to the right place, and so think, is there anywhere else where this would fit better? Or adapt the same idea. For instance, I work in mechanisms of disease, but if I'm applying to, and also in drug development for some diseases, but if I'm applying to a patient association, let's say, I try to do the more translational project, the thing that is more applied, and that the patient association will see more the bottom, the end of it, and not so mechanistic research. Basically, it's the same. It can be actually the same project, but I'm explaining it probably in a way that is more suited to that agency. So that's another thing that I think you can do. You can often, what I do is also try to increase the preliminary data. Meanwhile, as things go and come back, you're trying to build a bit more on that. And as you suggested before, to change the team, go recruit someone who has expertise and who can be in your team as co-PI, for instance, or as partner of the project, which would bring the required expertise.
Dr. Martin, Dr. Bafor, any thoughts?
Yeah, I think those are all excellent suggestions, and I agree with them all. For me, when one of my grants gets rejected, what I first do is I take a little bit of a break from the grant, because often you've put in a lot of effort and time and emotion, and often you feel angry and disappointed. And then it's not the best moment to actually read the comments, because you might not interpret them as well as you should. So I normally sort of try and take a break. And as Matthew, one of the previous speakers, said so eloquently, life goes on. So don't let a rejected grant poison the rest of your life. You know, it's a grant, and sort of try and partition it to what it is. And then once your emotions have calmed down slightly, then you have a sort of more sober view to look at it. Then to me, the first thing that I do is I carefully read the feedback that I've gotten. If you have a trusted colleague or collaborator, you can also ask them to look through the feedback to get a view of, is it worth reapplying to this specific foundation, yes or no? Because sometimes the reviewers are just so negative that you think, well, it's just going to cost me a lot of extra time, and basically I'm going to have the same problems no matter what I do. If you're not sure, then I would suggest that you reach out to a grants manager, a program manager at the funding agency, and ask to speak to them specifically and say, look, are you interested in this topic? Does this fall within your scope? Is this the type of work you are interested in funding? And then if they say no, then you know to cut your losses and go elsewhere. If they say yes, but we want you to make all these changes, then at least you know that you stand a chance if you then make all those changes. And indeed, like was suggested, sometimes it's a matter of finding other collaborators perhaps that can add extra expertise that you didn't sort of add to the grant, making the aims a lot more specific. Perhaps you were too vague with your aims, perhaps cutting the grant down a little bit. Perhaps you're a bit too ambitious with what you were trying to do. Perhaps review your budget. Perhaps the budget wasn't quite right. And then sort of those are things that you can look at. I would suggest to perhaps find someone else that you closely work with to also take a look at your grant and get their feedback. Sometimes it can help to have a fresh pair of eyes, look at your writing or your grant, and that they say, well, to me, that doesn't seem very clear. Often when you're very sort of focused on your own work, to you it seems very clear, but to an outsider, to a reviewer that is not completely in that same topic, it might not seem clear. So it never hurts to sort of get an extra pair of eyes of someone that you trust, obviously, because obviously you have to be careful who you show your grants to. But if it's someone from your lab or a close collaborator, then you could ask them, what do you think of the text? Does it read clearly? And then if it is completely rejected, if you say there is no chance, then what you can do is find other maybe smaller private foundations, maybe change the scope of the grant slightly, or repackage the grant to make it a lot smaller, where you just focus on one aim and then submit it to another foundation. But I think the trick is to never give up, to keep trying.
Absolutely. Dr. Bearford, do you have anything to add before we move on to audience questions?
Yes. So first of all, Browen, you took the words right out of my mouth. So basically, that's what I do. I've learned through my many failures that when I get a grant, I just usually, it's just a scanning I do the first day. When I get a response, a rejection to a grant, just scan through, because I'm always annoyed. I'm always frustrated, and that's okay. So if you are, that's fine. So I'm always, frustrated because, like you said, you've put in so much effort to it, and you just don't understand why you've, So what I do, I'm just sharing what I do. So I just scan through the first day, and I usually my go-to is 2 days. I don't look at it for another 2 days or so. But at least a minimum of 2 days, sometimes even longer. I do other things, and then sometimes I go back, do another scan, leave it again 2 days, and you find that when you're looking at it with a more relaxed mind, sometimes you can see where the reviewers are coming from. You're actually say, oh yeah, I agree with this. Okay, that's true, you know, looking back and forth. But at that first time, you're like, no, that's absolutely rubbish. This is wrong. The reviewers don't know what they're saying. I'm the best in what I do, and so on and so forth. So I do agree that everyone should take that time, you know, 2 days, whatever works for you. You know, take a step back, you know, come back to it, you know, until you can look at it with a better perspective. And then for those grants that don't usually give feedback, make sure to ask for feedback. Find out why, you know, your grant was rejected, and you'll be amazed. I do have an experience where I was rejected and I was told, you know, what I think I used the term, what went wrong, and the program manager said, no, your application was actually excellent, and you know, you were actually among the top 3, but we had to choose just one, and it was a luck of the draw, you know. So it does happen like that sometimes, you know, and that makes you feel good to hear that. But then you ask yourself, why wasn't I that one that was picked, you know, and things like that. But it happens, and then you go again. And I did apply again for one of them, and I got it. So it happens, you know, that way. Once you need to also reach out to, like Bronwyn said, you know, get feedback from as many different people, and from the program manager especially, because that's the institute you're applying to. So hear from their perspective what they see, what they want, and things like that, if you can get perspectives from them, and then put it all together again. And if it's necessary, then yes, please get additional mentors, co-mentors that are relevant to the field of expertise that you may not have had, you know, in order for them to look at it with you know, from their perspective, to help get it better. So yeah, just my tips as well.
Absolutely. No, those are all fantastic answers and extremely insightful. I'll move on to the audience questions with our last couple minutes we have left here. Please continue to put your questions in the Q&A section. Even after this panel's over, I think our panelists will be able to stick around and answer some of the questions over in the Q&A panel. So first question is from Samantha Room, who asks, how much of your time should be spent applying for funding? Is it a one-off process or is it continual?
I'm gonna answer that. I'm hoping I understood the question right. But for me, it's a continuous process. It depends on what you're looking for, you know, what you want. I mean, you can see when Matthew presented, he had applied for, you know, different types of funding applications. So it depends on what you're looking for. And I usually tell people, in my own experience, applying for grants is somewhat addictive, you know, for me. That's me. And that's because, you know, you keep learning and you keep going high and high, and you keep wanting to know and things like that, and getting funds. And where I started from, I started from Nigeria. And just like Patricia said, you know, research funding is quite poor there. And I had, you know, no other choice but to, you know, look for, you know, apply very, like, a lot for grants. And I had to, you know, it was a continuous process for me, because I needed grants for different research projects that I was doing, and also to get over here, you know, as well. I also needed to apply for grants. So I think, in my opinion, and also depends on what you're working on, what you want to achieve, what you want to get. It is a continuous process. But for some others, it may just be the one-off. So it all depends. It depends on the individual and what you want.
Thank you. Any other thoughts from Dr. Maciel or Dr. Martin before we move on to the next question?
No, I think for me it's also quite. I dedicate quite some time to grant writing, and I keep, you know, continuously.
Yeah. I think as a grad student, it's still a continuous process, but perhaps more punctuated than being a PI. Yeah. Obviously, as a grad student, we want to apply for our own funding, kind of pay our own way through. But with that being said, we're also still trying to get a degree and trying to complete projects for a thesis. So there are times, especially in my experience, where I've had to really kind of ramp down my research a little bit to write a grant. But as soon as I get it submitted, I'm back to mostly doing research. So I think it's a little bit different from the grad student point of view. But for PIs, it's probably a very continuous, seemingly never-ending process. The next question, excuse me, also from Samantha. Is there one central place where you can sign up for calls for applications? how do you know when funding is available? So how do you go about finding those calls for funding applications?
So at least my institution has some officers who look for for the main funding agencies, let's say, that are relevant for us, but only for the main ones. I receive some information from those officers. I also, of course, sign up to let's say, the foundations that I already identified as relevant for me, and so basically mostly that's my sources. And then if I have a specific project for a specific topic, I have to go browsing and have to find additional ones. But it's
fantastic. I will say that Dr. Kaylee added a really good link to a website under the question itself in the Q&A tab if anyone wants to go and take a look at that. Dr. Bafour, Dr. Martin, you have any other tips for looking for calls for applications?
I think, to me, the best place is to start within your university. Often within universities, there are grants officers, and they know about most of the common grants that are specific for that certain country or region. And they will also know the deadlines and what you need to do to get those grants. For example, how much experience you need, etc. So I think the first thing would be to find these grants officers within your university, see if they're there or not, and if they are, sort of ask them, can you direct me towards a resource of common grants that people apply for here. Like Patricia mentioned, another great thing is, especially for smaller private foundations, is to sign up to their alerts. So they'll send you an email when a new grants call has been published. So then you get an email, and then you know, okay, this might be interesting for me. A lot of universities actually have funding databases where you can actually, as a student or a postdoc or a PI, look up using keywords, for example, which grant funding is available for you. I know when I worked at the National Institutes of Health, we had access to some of the Johns Hopkins funding databases, which were actually very useful. And also the National Institutes of Health had its own NIH funding database, so you could actually look up to see which calls were coming and which ones were relevant to you. Here at the University of Antwerp in Belgium, we don't have that yet, but I'm trying to work together with a bunch of other people to set that up. So if your university doesn't have it, it's always worth going to talk to the research department, especially with a few senior researchers, and to say to the research department, we need this, because I think it saves you a lot of time, because often searching for funding can be time consuming. I see that as well as part of my job. It's quite a time consuming task. So the less time you can spend on searching for funding, better.
Fantastic. Thank you for that. I think we're nearing the end of our time. So in the interest of everyone's time, I'll go ahead and thank our panelists for all the fantastic information that you've given us today. There's a couple more questions in the Q&A if any of you have time to pop over there and answer. I think there's one more question that we didn't get around to. But for the attendees, we're now going to have a 15-minute break. Again, the panel will continue to kind of monitor the Q&A. So if you have any other questions, please add them. And our next session will be at 3:45 BST, 10:45 Eastern Standard Time with Dr. Olya Vidinsky on identifying and dealing with burnout. So thank you all for your time.
I'm on mute. There we go. Thank you so much, Jasmine. Thank you so much to all of our panelists. And we will see you again in 15 minutes' time. Enjoy your break.
Hi everyone. I'd now like to introduce our next speaker. Dr. Olya Vedenskaya started a career studying medicine, specializing in medical biophysics, and she worked on her MD thesis devoted to traumatic brain injury and mass spectrometry at the University of Pittsburgh in the States. She did her PhD in Berlin, in Germany, working on a multi-omics approach to research of liver cancer and precancerous conditions. She continued her work in translational medicine and mass spectrometry in Dresden, And during her postdoc, Olya established local and global academic mental health initiatives, including co-founding Dragonfly Mental Health. We are delighted to welcome Olya to LabLife Con and listen to her talk on mental health, identifying and overcoming burnout. Over to you, Olya.
Thank you. Wonderful. So yeah, first of all, thank you so much for this opportunity for me to give a talk, and I'm very happy to see how Hello Bio builds the community. So I think it's a great example for all the companies out there to support their communities. So first and foremost, I would like to start my presentation with just underlining once again that if you are at the crisis right now and need help, there are options which you could use at the moment. For example, you can go to Samaritans.org and some other local helplines. And not only they have 24/7 hotlines for talking, they also have chats option, which is really good for people who don't like to talk on the phone, who feel uncomfortable about it. And also, you can always walk into a local ER even if you don't speak local language. I also would like to give a disclaimer that Dragonfly Mental Health and I myself here we're not a healthcare provider. So the information provided today does not qualify as a medical advice and doesn't substitute for speaking to a medical professional. So today we're going to talk about Dragonfly Mental Health. So Sam already gave me a personal introduction, so there will be no personal introduction from me. Then we'll go through basics burnout, and I would like to underline once again that we're given the peer perspective on burnout. So it's not a talk about how to change the system. This talk is not about it. This talk is about how to help you as a person and how can you help yourself, and maybe how you can help a couple of others who are next to you. Then we'll talk about what helps in burnout, and then we'll finalize it with a group discussion. So burnout. What's important to underline, interesting, I have some glitches in my presentation, sorry. That mental, give me a second. The mental health is actually a spectrum. So it's not just healthy or not healthy. There's a whole spectrum of the things and of conditions. So first of all, it's mental health. Well, the person is striving and performing and feeling the best. So when the stress kicks in, when it's managed properly, when we deal with the stress, we still function properly if the stress is manageable. And if the stress is not manageable, or if it's been there for a very long time, then distress can come. And then if distress is not taken care of, so in distress, we tend to eat less or to eat more than we used to sleep more or less than we used to, or which is not normal for us. And things like this. So if this is not taken care of, then disease kicks in. And in case of burnout, eventually it can manifest in depression or in any other things. And then if this is not taken care of, then the crisis hits. And then person may have suicidality behaviors or thoughts and things like this. So in order for all of us not to hit crisis and potentially not even to hit a disease, we need to take care of a burnout right in between distress and disease situation. And that's where the burnout is. What I would like to underline here, and it's important to understand that scientific settings are unique, whether we're talking about academia, whether we're talking about industry. In both of the cases, while we were studying and moving to industry, so universities are typically supporting master's students or bachelor students because they're considered to be still kids, so they need more support. And then universities and companies don't really take care of us when we're transitioning from PhD student to postdoc, or from PhD student to industry researcher and stuff like this. And of course, academia comes with the fact that there are cultural and systemic barriers, and it makes scientists less likely to seek support. And overall, postgraduate education and a follow-up career path in industry or in academia, they all come with unique pressures and a culture deriving from academic stigmatized environment. WHO, World Health Organization, defines burnout as it says it's a syndrome, so it recognizes it as a syndrome resulting from chronic workplace stress that has not been successfully managed. It may manifest as a feeling of energy depletion or exhaustion and or increased mental distance from one's job, or feelings of negativism or cynicism to one's job, and reduced professional efficacy. Who can suffer from burnout? Essentially anyone doing a goal-directed activity, not only scientists, not only researchers, not only PhD students. If you're a volunteer and you're doing goal-directed activity, you can be an athlete, parent, caregiver, clinician. All these people and occupations and professions, people can suffer from burnout. What are the core components and symptoms? There are two core components. First one is the self-reflection. So this is interesting. I'm struggling. There's some misplacement of some words. So my apologies about it. So essentially, when the person is hitting burnout, they may experience emotional or physical exhaustion. And when it comes to their own self-reflection component, reduced emotional regulation can manifest in behaviors like binge drinking, self-harm in hair pulling disorder, cutting, and other kind of things. So then of course it can be cognitive impairment when you feel like you read 20 pages or you read 2 pages and you still don't know what it was about, so you have to reread it again. The same comes with the reduced memory or attention to the things, and sleeping problems. And the interactions component can manifest as being easily irritable, can be manifesting as withdrawal and distancing from your peers, from your colleagues, from your family and friends. You may detect that you have reduced performance. Also, you may feel that you're not that flexible anymore, and you can be cynical about your work. And it's important to underline that burnout is situational. What it means, that burnout can be one-dimensional. For example, burnout can be work-related, but it may not affect other work, or other like bench work. Or for example, it may not affect your personal life, and you can just feel burned out and be burned out about the work. Also, maybe a person struggling from burnout may be able to contain or manage symptoms. So we tend to call these people high functioning, but it's rather probably the surrounding is not allowing them to actually show that they're burned out. And there's a common misconception that if it's non-lethal, so I have to learn how to live with that. And of course, we do not support this opinion. We don't want people to feel that, I'm still managing, so like I don't want to get a support. I don't need a support because I'm still managing. So essentially it's like, then the question comes up, so what would be the fine line when you're not managing anymore? So instead of getting treatment and support and help while you're still managing, you shouldn't wait probably until you cannot manage anymore. Also, of course, every day may be different and require different management. Sometimes we're coping more and better, sometimes we're coping less, and it doesn't have to be constant all the time. Burnout is not static or inevitable. It sometimes can be more burnout or less burnout or things like this. And also it's you can avoid it. And now I'd like to talk about the causes, and it's there are multiple causes, of course, and researchers talk about it doesn't necessarily have to be one cause. There can be many more, and of course, when there are more than one, it's more and more difficult for people to deal with it. First, and like WHO has already underlined to us, that chronic stress relating to work and other ongoing activities, and the stress is not managed well. However, there are other things. For example, the lack of control. It doesn't really matter whether it's a real lack of control or perceived lack of control. It still can cause a burnout. When we're talking about the real objective lack of control is that, for example, you promised your collaborators to deliver something, but then the supply chain was affected, so you didn't get the EPIs, therefore you cannot ship the samples further down the line. Lack of control, yes. May lead to burnout, yes. The perceived lack of control, of course, is sometimes when you just feel like you're not on top of the things, and like in reality things may not be as bad, but this is how you feel it, and it also can lead you to a burnout. Of course, important to underline, bullying or toxic environment at work and relationship, microaggressions, which all of us once in a while experience, of course. These things, they lower our self-esteem or our mood, and eventually like our wish to stay at this working place, and they're of course leading to a burnout. Work-life imbalance is one of the things which are not good in case of developing the burnout. And of course, it also comes to the lack of control, that extra job duties but limited authority. So if you are a PhD student and you have already a lot on your plate, and your PI tells you that there's more you should do, you're not in the authority, and you don't feel that you're in authority to say no, then of course it will lead to the point of you having too much, and potentially can lead to a burnout. Disconnection from values is something which we face, or some of us face, when we're working, for example, with when we're doing animal experiments, and if you're not an authority to say that your beliefs are not allowing you to, or your moral values are not allowing you to work with animals, you'll still do it and you'll struggle through it. So this is something which can lead to a burnout. Lack of identity beyond work is something which a lot of scientists struggle, because we self-identify ourselves as a scientist. And if we don't have anything outside of us being scientists, if we don't have something to basically stand on, each and every time we fail the experiment in scientific path, we will feel like a personal failure, which is not the case. Science is a lot about failure. Experiments are a lot about failure. So this lack of identity beyond work is really essential. And finally, I'd like to underline this, is sometimes non-solvable essence of work. So if you have a long project, 3, 4, 5 years, and you do have a deadline when it comes to your PhD or a postdoc contract, but you don't have a deadline, like you cannot post this deadline on the nature of your work, or some questions are just at the very moment of science development are unsolvable. So constantly every day facing some questions which you cannot solve is something which can easily lead to burnout, and the longer you deal with it, the more the chances are to develop one. So next, I'd like to talk a bit about burnout cycles. So when you know about the burnout cycle, you can potentially track yourself somewhere there and see, okay, here I am at this very point of burnout. So your solutions will be based on at the point where you are at the burnout cycle. So as we talk, there are some causes which leads to symptoms, and symptoms, of course, worsen situational causes. And all in, it leads to lower employee satisfaction and accomplishment/productivity. And if we're talking about the components of burnout cycle, I'd like to start from exhaustion, because all of us once in a while experience that. So when we feel exhausted, at certain point, we're hitting the bar where we're saying, you know what, I don't care anymore. So then we're hitting cynicism. And if you stop caring anymore, you also will take yourself out of the community discussions, journal clubs, beer hours with your colleagues. So you will withdraw yourself socially, which will eventually, taken together with exhaustion and cynicism and all in, will lead to a lack of concentration when it comes to work. And of course, when there is a lack of concentration, at a certain point, you'll be inefficient. And at a certain point of this inefficiency, you will not have the work you plan to do done, which will lead to work extension. And then when the workload is extending, then it leads to exhaustion again. So each and every time you hit this circle again, it gets worsened. And it's important to underline that you can break out of this cycle as long as you understand that you're somewhere there. Statistics that up to 76%, according to 2020 studies, and like, you know, it was asked in 2019, so that was pre-COVID actually, 76% experience burnout at the job at least sometimes. So we know that it did worsen during the pandemic for scientists, and 70% felt stressed and fatigued, and 35% felt angry. Oh, there's some problem. So essentially 50+% that they're actually considering changing their career and either retiring earlier or leaving academia. But things are not that bad. So here are the things which can be done, and a lot of tiny things can be sort of planted and grown, and then there is a chance that you'll feel relieved. So there's several components to what can be done. First of all, education and culture change. So talks like this and participation of people. So hopefully you'll go home today, or you go back to the lab, and during the coffee break with your colleagues, you can actually tell them, you know what, like we all have burnout at a certain point. Let's not stigmatize it. Let's talk about it. So it's important that there is a destigmatization and education about this topic. This part leads to a social support, because when you feel that you're comfortable talking to your colleagues about it, most likely you'll be supported. Of course, sometimes we do have toxic colleagues. This is unavoidable, but there are peers who will support you. It's essential to balance rest and effort at work. For example, we strongly encourage everyone to take complete vacations and not small crumbs of it here and there, so you actually feel disconnected from work for a little while. We suggest that you commit to taking regular breaks, and it's important that you understand that breaks are different. So if you feel like going to have a break, like I need to have a break, so I need a break from writing and it will be a bench work, that's not actually a break. This is a change of your activity, but you are not resting. And so please keep in mind that what you need and when during a break is rest. So we suggest that maybe you can have like 50 minutes of work plus 10 minutes break, or half an hour and 5 minutes break, whatever fits you better. You could experiment a little bit with this, but of course some breaks will be necessary, like going to restroom, eating or drinking, and some are efficient, for example, different work-related activities, but please focus on the joyful ones. Take a coffee break with a colleague, go outside, I don't know, do something which is actually joyful, which will make your brain think that it's resting. Improving basic health is essential. So of course it's mindfulness, sleep, and exercise. I wish I'd tell you something easier like a magic pill. No, there's still, these things are essential. I'm coming from a former Soviet Union cluster, so of course things like mindfulness did not really exist there, at least not in my environment. And a couple of years ago, I just got dragged into mindfulness, like guided relaxation and breathing exercises and all these kind of things, and they do help. So if you're a skeptic and you're thinking, oh, whether it's going to work or not, yes, it will work. So please try it out. And improving work communication. So try to negotiate better working hours. Try to improve work accommodations. COVID showed all of us, including our PIs and bosses, that we actually can work from home at least part-time. We've got a Managing Upward talk on our YouTube channel. So if you feel uncomfortable or not empowered enough to discuss the things with your PI. And if you're a junior scientist, please have a look. There are multiple suggestions and workshop how you can do it. So yeah, essentially that was it. And the other advices I have already mentioned is please don't internalize burnout as a failure. It's a consequence of a system that expects a person to work long hours and sacrifice their personal lives. Try to create ways to detach from stress and normalize conversations about mental health. Try to fight isolation and treat yourself like a tree. So it's sun, air, nutrients, and whatever nutrients for you are, whether it's going outside and exercising or binge watching series on Netflix, both are your nutrients. So with this, I'd like to finish my talk. I would like to apologize again for a bit of a mess on the presentation. I would also like to ask you to please fill the survey. If you have a couple of comments, help us to improve this talk. We're constantly working on improving our programs. So if you have any comments, please let us know.
Thank you so much. Oh yeah, and please don't worry about the slides. They were absolutely great, and you were great. I think there's so much in that talk that I think we could probably have an entire conference around mental health.
I reduced so much. Like, what can you do in 15 minutes?
Oh, I know. We've got a couple of questions, so I'm just going to field those from the audience. But after this session, please do pop the link to your survey in the main event chat so that people can
awesome.
fill that
Thank
out.
You.
So we've had an anonymous question, which I thought might happen around this because it's such a sensitive subject. And this person's asked, if you spot, armed with this knowledge, that you have a colleague who is in that social withdrawal phase, that first phase of burnout, and you can see the signs, how would you then approach helping or supporting them?
Oh God, thank you so much for asking this. First of all, we regularly get this question, and this question is, the whole topic for another seminar. What I would recommend, and briefly what I can say, first of all, internalize the fact that it's not your responsibility to help them. It may, however, be your problem, of course, if it's they're your colleague, but it's not your responsibility. And it's extremely important that you differentiate these two things in your mind. And what you can tell them is just to be open. Just say, I am here. So you don't have to tell about them about them, but you can tell them how you feel. So you can tell them that you are worried that they're in the phase of withdrawal, that you are worried that you stand here, and if they feel that they would need to talk to you or they want to talk to you, then they could reach out. So you can only sort of like underline where you are, and you are wanting to help them. So this is something which we usually say. And of course, it can go to next levels of, you are suspecting that person has suicidal thoughts and behaviors, and this is another topic. But in any case, it's recommended to be open about it and say that I am worried, I am suspecting that things are not well for you. What can I do to help you? How can I support you?
Yeah, absolutely. And we've had two questions that are sort of the same, so I'm going to roll them into one. So Sam from Hello Bio has asked whether there's any resources that are available for PIs or supervisors that can educate them in what burnout is, what to look for in their postdocs or their PhD students. And then Matthew Wilkinson, one of our attendees, has asked what changes can then staff at universities and institutions then make to help prevent burnout in students and staff. So kind of resources to help spot the signs, and then if they spot them, how as a member of staff responsible for students would you then deal with that?
I got this Now you're putting me in the horrible situation of self-advertising. So
Go for it.
we got a talk on YouTube about burnout, and of course it has it underlines more. It's like it's accessible for everyone. It has there are many resources talking about burnout in general, but not that many talking about burnout in academia. And typically the publications focus on statistics and on causes, but solutions, which we talk today about, is is something which is up to you as to a PI or as a team lead. Try to have a look at the presentation we got on YouTube, and also the symptoms which I talk about today. This is something which you could actually see in your students, and if you're not sure, just ask them. And then when it comes to creating the environment where like it be more supportive for your colleagues and for your mentees, then it's not a one man's job. It's one man's job to ruin the environment. Yes, one person can easily do it, but creating the supportive environment is something which is not like an overnight process, and you need to find a supportive teams. You need to hire supportive people. You need to hire people who are open about it, who destigmatize the topic about mental health, who themselves appreciate work-life balance, so they will not impose imbalance on others. So there are ways, basically, and I don't think I can cover all of them. So it's like, I think it's a subject of consulting, probably. I hope this semi answers the question.
Yeah, I think that's so important about it be the importance of it being a team effort, and the importance of it being a cultural change that everyone has to buy into. And then absolutely gaining that external perspective from a consultant can be so helpful to uncover things that you haven't seen. And I think also have colleagues be more honest talking to someone that is external as well, if you're looking to uncover issues as well.
I remember how this happened in my previous lab, actually, and I think it's a wonderful example. I was working in the lab, and I had wonderful colleagues, and one of them was like super withdrawn, and he's the last person who I thought would care about me, actually. And then I had a prescription for my antidepressants in the lab bench, because I just came from a doctor. And then in Germany, it has like a very specific format of a red color paper, and he was passing by and he was like, what is the medicine for? And I'm like, I was tired of not talking about it. So I said, it's against my depression,
Yeah.
And he said, really? I'm dealing with it through a therapy, but it's so important that you talk about it. So now, do you want to talk about it, actually, that now, all the things which we're dealing with, and so on and so forth. And so one event like this can start the whole destigmatization.
Yeah. 100%. Well, thank you so much, Ola, for that talk. That was so important. And please do make sure that you go in after this talk into the event chat and share that link
Awesome.
for our attendees to fill the survey out. So thank you so much.
Thank you.
So I will hand back over to Sam Room now to introduce our final closing speaker. Over to you, Sam.
Okay, well, I am really excited now to welcome Dr. Joanne Kamens to LabLife Con. Joanne is a senior consultant at the Impact Seat, a consultancy practice which brings science-based DEI, that's diversity, equity and inclusion, knowledge and practice to organizations. Joanne received her PhD in genetics from Harvard Medical School and has had a varied career in academia, pharma, biotech and nonprofit. While executive director of AdGene, she experimented with practical ways to create an inclusive workplace. Joanne maintained single-digit employee turnover for almost a decade at AdGene and collaborated with dozens of inclusion organizations to make the company a best place to work in Boston for 6 years running. So in our closing keynote talk on STEM career paths for life scientists, Joanne is aiming to inspire you and provide specific tactics for charting a course for a happy and long-term career in science. So over to you, Joanne. Oh, I think.
What a great lineup of speakers you have assembled today. So great job, Hello Bio. Really impressed. So, okay. So a lot of the talk that we've had today so far has been a bit focused, I think, on an academic, the academic career struggle and path. And I would say that, I'm going to show you that the vast majority of you will not be in academia a few years from now. So I'm going to go kind of quick through these slides. So I hope to have time for questions at the end. So before I start, I just want to do a native lands acknowledgement. I don't like to be performative about this, so I'd like to make a suggestion to increase the diversity of your news streams. So Duncan McHugh is a Canadian activist and radio personality for Native and Indigenous lands rights. And one of the cool things is if you go to his website or find people on social media that you want to follow, Twitter, for example, suggests other people that you might want to follow. So it's really important to hear about Indigenous peoples' struggles, their goals, and native land, issues from the people themselves. And so that's generally true about inclusion work. And so I would say I should also acknowledge that here in Newton, Massachusetts, I am on Pawtucket and Massachusetts land, where I do my work from at home. So what I found over my many years of working with scientists as a mentor, advisor, peer, everybody thinks this is how we make decisions. We have a hypothesis, we test it, we go back and tweak the hypothesis. And, but when it comes to career decisions, this just goes right out the window. And scientists think that they're doing that, but actually what they're doing is just like, oh, this sounds like a good idea, but they don't get data and they don't really use any of their scientific skills. So my goals today are to help you think about how you might use your scientific skills to make decisions about your career. This is also a call to action. I really wish that, career and future planning was a part of your curriculum, like a required part, but it's really not in most places. So you're going to have to seek data yourself and go out for it. That's going to be your personal responsibility. I am working at a systemic level to make these good mentorship and career support more a part of the life science, career training, but we're not quite there yet. So a lot of times what you're hearing is this language that, you've left academia. You're wasting your PhD if you leave academia, and then leaving science can be a good career decision. The fact, and in the other direction, illogical myths keeping talented PhDs stuck in academia. The fact is, you're not leaving science. You're never going to leave science because you're a scientist. It's something you are, not something you do. And you take that training with you wherever you go. And it's a really normal thing to get training and then move into a career. And it doesn't matter where that career is, whether it's in academia or not. So if you're feeling internal guilt or pressure about, something that you're selling out, this is so much not the truth. And I would like you to contact me if you are having trouble embracing this contact. So it's really important that you embrace this, because here's some data I'll share from the US and then I'll share some from the UK. Those orange lines are the total faculty positions that are available in our fields. And the blue line is the number of PhDs being awarded up through 2011. I guarantee you this picture is not getting any better. There just aren't enough tenure track jobs. And by the way, nor do there need to be, because I guarantee you that not every one of you belongs as an academic professor. I certainly did not. I moved right from my graduate work to a pharma position, which I really loved and thrived at. That was the right position for me. So my goal is to help you find the right position for you and have the right people stay in academia. I love the apprenticeship training model, so I'm not trying to discourage people. I'm trying to encourage the right choices. This is some data from the UK, from some Wellcome research. That little teeny tiny arrow at the bottom, those are the tenure faculty professor positions, 0.49% the year of this data, 2010. So, these are hard data. You have to think about early, you have to start thinking about your career. And as I mentioned, this may not be a formal part of your curriculum. There's a lot of conflict of interest with your lab and your PI. They want you to stay around for a really long time because the better you get, the more useful you are in the lab. So even the very best mentors are somewhat in a conflict of interest situation, the way our systems are set up. So you really need to be watching out for yourself and taking ownership of your own development. So how did I get here? I'm going to talk about my career through 4 different lenses. I actually moved from academia to pharma to biotech to nonprofit, and now I'm doing consulting. And I did a short stint in academic administration before I started my current gig doing diversity work full time. So I'm going to go through 4 different versions of this career path. The first one is, how did I meet people? I know that everybody hates the word networking, so I don't use it. You need to build relationships. That is how people get jobs. I love this data. 52% of scientists, about 1,200 scientists, said that networking was how they got their job. But like all these other categories are networking as well, right? And LinkedIn is the networking website. So something like 86% of people get jobs because of the relationships that they have. So why is that true? So this is some other data that I found interesting. 7% of applications to jobs come from referrals. That means a networking relationship. But 40% of hires come from referrals. And this is because we really love to know that the person that we're hiring is not going to do some off the chart thing. Like you hire someone and 2 weeks later, they pull a knife on someone at the lab who borrowed their pipette. That actually happened to me. I had to fire them. But if I had known people who knew that person for a long time, I would have some feeling that they were a decent person to work with, a pleasant person to work with. And then you still get you the job, but referrals and relationships often get you the interview. I know that you hate networking. Please watch my YouTube videos. Or you can Google me. You can find those videos online. They're in a couple places. I also have a number of blogs. You really want networking to feel normal. I don't suggest that you do weird things to like fake card exchanges or go to events if you're introverted. That's not a good idea. But what you can do is get involved on a committee. Be open to relationships. And I don't have time today to go into the full hour of tips that I have, but if you want some actionable work, again, you can reach out to me or look through some of my content online. So how did I get here as far as relationships go? My first job was a referral. My academic PI knew people in industry, in the pharma industry, and he helped me get my first job through a direct friend of his. He introduced me. My second one, I was hired by someone who I had worked with and knew, who was doing a startup in RNAi with Craig Mello, and that was really fun. When I went to Agene, it was a referral and direct contact. So both of those things were in play. And finally, I just joined a consulting firm with people that I've been working with for 10 years on diversity issues in general, especially for women in entrepreneurship. Although we do all kinds of equity and inclusion work with STEM organizations. So that's how I got all my jobs, all through people, every one of them. So, okay, that's the first lens, is knowing people. The second lens is professional development. And you do need to learn the science. You need to learn it well, and you need to be good at it. It's going to be a crucial skill. But there are all kinds of other things you need to learn. They're not soft skills. There's no such thing as a soft skill. They are plus skills, and they are vitally important for academic or non-academic jobs. And you can do a lot of that training while you are in school. I have a lot of also content on this online. I'm not going to go into detail in this talk, but these are the 5 kind of top areas you want to work in: communication skills, technical knowledge, teamwork, managing people, and leadership potentially, if that's of interest to you. Why managing people? If you do stay in academia, your path is actually to be a lab head. That's what you want to probably do, or lead a group. Perhaps you lead a group of educators in science, in academia. If you leave academia, you certainly are going to work with other people, and you're often going to manage people. Okay. And you know what? When you get out of grad school, and if you do a postdoc, you are kind of old. So they're going to think that you know how to manage people. And if you have no practice and experience with that, you are at a distinct disadvantage, for not just for getting jobs. You can probably get them, but can you do well at them? So these are all skills that you can learn while you're training. Feel free to reach out to me for more information on this, or I do have a number of, I point to one blog here. Maybe Hello Bio wants to cross-post some of this content. There's a lot of things you can do. Okay, so that was lens 2. Lens 2 was always doing professional development, raising your hand all the time. So, and actually I should say, in my pharma career, anytime there was an opportunity to take any type of training that might be applicable, because in a large company, you have all kinds of opportunities for this, I raised my hand and did it. Did a collaboration with Japan? Yes. Became a beta tester on our database? Yes. Whatever anybody asked me to do that was new, I focused on that. To me, the definition of being a scientist is always learning. So that's actually what we enjoy anyway. Okay, so lens 3. Way back when I was starting out at BASF, which became Abbott in Worcester here in Massachusetts, I woke up one day. I was not very senior in the company. I was a senior scientist at that point. I had been there a few years. And I look around for a week and I see not a single other woman in any meeting that I'm in the whole week. And in grad school, it was 50-50 women and men, speaking from a binary perspective. So about half, women for men and a smaller percentage of people who were non-binary. It's actually 20 years later, that percentage is slightly larger as more people are able to bring their full selves to work with more awareness of those issues. But the issue was, there were a lot of men, and mostly white men, I'm going to say. I own my privilege as a white adult, but as a woman in science, I did not have that much privilege. And there was a lot going on that was preventing me from advancing and being successful. I can tell you some of those stories perhaps at the end if you have time. So academia doesn't leak as far as gender goes. It gushes. Women are excellent students. They make it through grad school 50-50, sometimes even more women than men in these programs, but they do not advance. I do not have time to talk to you all about the leaky pipeline, the gushing pipeline of science. Please reach out to me if you would like more resources on this. This should not be news to you. If you are a woman, you're certainly experiencing it. And if you are an ally and not a woman of any other gender, then you're aware of it. By the way, intersectionality issues, that means you're a woman and you're Black, or you're a woman and you are LGBTQ, or you're a woman and you identify as Latina. Whatever those intersectionalities are, your gushing is even worse. More and more of those people with intersectional identities are leaking. And it's not just about gender. These are, you can see these data for the dark blue line is the number of PhDs given to under-recognized and marginalized scientists. And then these much, much less effective lines are those that are actually getting faculty positions, right? So it's really the inequities in science are having an incredible impact on the lack of diversity, which of course affects the world because science really needs to be done by everyone. So this is very problematic. I, of course, was very disturbed by this. So it's not just caused by harassment and bullying, although that is happening. I don't need to tell you about what's in the news, all the bullies. And so the Me Too movement really brought this to the fore, and we're finally starting to see some of these people accountable for their actions. This is a slide from Dragonfly Mental Health, who I mentioned in the chat I admire incredibly. Sexual harassment in academia, get this statistic, second highest rate of sexual harassment of any professional industry. There's a lot of reasons for that. If we have time at the end, you can ask me if you're interested in that. Has to do primarily with the fact that lab heads have no accountability. They don't really have a boss, and their organizations are not holding them accountable. So, this is going to cause issues of why are women leaving academia? Why are LGBTQ and non-binary people leaving academia? Well, this may be why, and it's certainly one of the factors. It's not the only factor, although sexual harassment is not rare, as we know, as I just told you. This is the 2020 Welcome Report that talks about international UK and US. And basically, scientists just are not comfortable because they know a lot of people who have witnessed or experienced bullying and harassment, but they have a great fear of negative personal consequences for reporting it and doing anything about it. So we are not doing a great job solving this problem. And but that is a big problem that affects a lot of people. But what affects and that's the tip of the iceberg, those really bad people. And one by one, we are starting to see them lose their positions, lose their funding. NSF and NIH are starting to take a harder stance on this, and also preventing the harasser. That means like a harasser is identified at one organization, but then they go to another organization and just do just as much damage. So what really is going on, though, is not just that tip of the iceberg, though, but it's the iceberg that below the water is bigger. And these are all the things, and not just as far as gender, but the bias and microaggressions and exclusion and mistreatment of marginalized and marginalized groups of people, that this bias is what leads to the wholesale inability for us to effectively diversify our science workforce. So I don't have time today to do a whole workshop on implicit bias. You can Google that. You can Google me talking about implicit bias in some conferences. There's a lot you can learn. Self-educating is one of the best ways to start being an ally. And so I urge you to get involved. The generation of scientists that are coming up now cannot ignore the fact that we have major issues of equity in science. We have major issues of equity in the world, but as I mentioned, our academic training system particularly bad for these types of issues. So how did I get here? Lens number 3, that's volunteerism, diversity. I got angry about something, and I got active, and that really created a whole network for me. All the other people I was meeting that were angry about the lack of equity, diversity, and inclusion in science, those are the people that became my network, but through very deep relationships because we worked together on something that's meaningful to us. And for me, decades later, it turned into a full-time job, which is the work that I'm doing now. So lens number 4, people talk about work-life balance about scientists that have children or don't have children. I had a kid in graduate school. I had another one my second year working in pharma. Now my parents need more help. There's a lot of things going on. There's always going to be life issues. You could have health issues. Your partner could have health issues. You could be looking for a partner and not have time to do that, and you want one. You could want to do horseback riding as your avocation. You could be wanting to volunteer like I did to change the world's look at diversity and inclusion. Whatever the work-life issues are, you are going to have them. They're not just about parents. They are a part of everyone's life. So what's really crucial is that you pay attention to your life. We had some great talks today that touched on this issue of protecting yourself. The number of women in particular, and men also, and all genders that I speak to that think that they're going to wait till after their postdoc to have a baby is ludicrous. This isn't an issue of equity. This is a biology issue. It is harder to have children and healthy children as you get older. So I'm not saying everyone should have children, but if you want to, and then you are in a healthy relationship and you want to do that within a relationship, you should not wait until you are 38 to start doing that. That is my advice. That is my candid advice about that. And I will give it to anyone who wants to ask me about it. It is a huge problem that we defer our lives. And certainly we shouldn't be deferring our mental health, our wellness, our mindfulness. Oya gave a great talk about that and really, really embrace that. You need to be choosing labs that make space for life. So I have a lot of content online about work-life negotiation. And I will tell you just a couple facts. One is I'm Orthodox Jewish and I do not work on the Sabbath. So in all of my entire many decades long science career, I don't use my computer, my phone, or do anything except read. I do a lot of science reading. I love to read and I love science. So we can read on the Sabbath, but from sundown Friday till sundown Saturday, that day is a day of mindfulness, time with my family. We eat together. We probably eat too much. We play board games. We play Settlers of Catan. I've been playing Scrabble with my husband almost every week for some 33 years. Whatever those things are, we spend quality time together with no phones, no social media, no computers. So if you want to create work-life negotiation, I strongly suggest that you start by carving out some time with your loved ones, whoever they are, that's not distracted by your phone telling you that you should be working. This is super important. So what I hear from people is that they choose labs with advisors that have no understanding of work-life negotiation. In the old days, and still prominent as a common structure, the PI is a man, a self-identified man who has a partner, usually a woman, at home who's taking care of his household. And that allows him to work all the crazy hours that he wants. And if you have a PI like that who is not embracing an understanding of a more reasonable work-life negotiation, especially for families where there isn't someone at home taking care of the household and doing all the other stuff that frees up a person. Most of us can't afford to even live like that anymore, or nor would we want to. I don't have a job. I have a career. I have a passion for science. So really, really have to think about making good choices. And that means doing a lot of research before you choose an advisor. It should not be because you like their science. Should be because you like their mentorship and their style of managing the lab. Again, a lot more content about this online. 15 minutes is really hard to fit in all the high points here that I want. So finally, the last thing is how I got here is life. All these things are going on in my life. I have a lot of hobbies. I'm a voracious reader. I read about 100 books a year. I have a granddaughter now, and if you don't think I want time off to spend time with her, I need balance for that, for sure, because that is a great joy in one's life. And so, always seeking mental health through balance and through really seeking out and still having a passion and a successful scientific career. So please don't stay in a position. Really think about moving if you have an abusive or unsupportive PI that allows you to have mental health, work-life balance that you need. So how should you feel? Well, work is hard. I'm not going to lie. Some parts of it are unpleasant, but you should be happy enough that it doesn't make you miserable, which can ruin your home life as well. Things sometimes fall into place. You should occasionally feel confident because you have supportive people around you and you feel confident in your abilities. I'm not saying we don't sometimes question ourselves. I thought Matt's talk was excellent. But hopefully you're not being caused to feel imposter syndrome by people around you that are bullying you or gaslighting you or making you feel bad. Sometimes you just really like what you're doing. And so sometimes science to me just doesn't feel like work. And that's where you want to be. And if you're not there, then you really need to think about what you're doing. And my last words are, treat this like a research assignment. You really want to educate yourself and get data on career decisions. Don't take no for an answer. Just doing the bench work is not enough during your training. Every other field, every other career has career readiness as part of their part of the training, part of the work. You're not getting paid enough. You're getting paid like barely a living wage for the level of education that you have. You have to use that time to also prepare for your career. Make sure that not to bring an whiny academic attitude outside of academia. We have a certain angst in academia. People outside of academia want to work with people who are happy and energized and pleasant. So I've been in so many interviews where I interview people and they're just depressed and miserable. First of all, please don't be depressed and miserable. Science is hard. It shouldn't torture you. And finally, activate your network and nurture it. And you have to do that now. You can't wait until you need a job. You have to start developing your network all along the way, because it's the people that know you well that will help you when the time comes. So I'm very happy to take questions. One thing, if you are starting to do a career search, and you could start that as early as year 3, educating yourself about what careers, actually, you could start that while you're an undergraduate. Check out the seismic.com job board. It's very specifically geared for life scientists in particular, and you may find it useful if that applies to you. And also, I just put out a video series at iBiology on peer mentoring, which if you don't have a supportive lab PI, or as was suggested, you want more mentors in your life, peers make fantastic mentors, and they're going to step up and they're going to form a great supportive community for you. So check out that video series. Also, here's my LinkedIn profile. If you have questions, you can reach out directly for me. You can scan this little QR code, which is a new thing since business cards are gone. I think I'm allowed to stay on and take a few questions. Thank you very much for joining me.
Absolutely. Thank you so much, Joanne. There was so much in that. I feel like every one of your slides could have just been a whole conference. So that was brilliant. Thank you. We have we have 4 questions from the audience. Okay. So it would be great to get through all of them. And if there's no time, feel free to direct it to more information. But I'm just going to ask one question quickly, which is one of our attendees is asking if you will share your Pokemon Go friend code.
I won't do it here online, but reach out to me on Twitter, or I'm on Discord also, if you can find me on Discord. So I don't want to do it here online because I don't think I can get to it fast enough. But sure, I love to friend scientists on Pokemon. I'm about to level up too, so I get to change my slide.
Amazing. So Matthew Wilkinson has asked, how do we change leaving academia being perceived by some people as a failure?
We just all have to start talking about how it's not leaving academia. It's finishing your training. That is what people do. My son went to school to be a mechanical engineer. He finished his training. He got a job. That's what people do. Literally, not all of you should be going to academia. It's not the right job for everyone. And it's also just, there aren't a job. And I want you all to be scientists 5-10 years from now. I don't want you to leave science because of, the applicability. If you are in a work training location where that is the attitude, I would toot sweet do everything you can to get yourself to a lab that supports multiple career paths and celebrates that. And there are many great mentors who perform that way. So I can't emphasize this enough. And it really, seriously, contact me if you need a pep talk. I do this all the time. You are not letting anybody down. You don't owe anything to anyone. you may not be getting, you may not be paying for your PhD, but you are seriously getting underpaid. And as a postdoc, you're dramatically underpaid for the level of skill and talent that you have. So your training system owes you the right training to get a job so that you can support your life. I didn't have the kind of money where I'm like doing this for fun. I am also supporting my life with my career. And so you don't owe anything to anyone.
I love that. I think someone asked earlier during Matthew Cayley's talk about affirmations. I feel like you just gave us like 5 affirmations.
Please, yes, please affirm. I am a scientist. I can do anything. And it is not just be a professor. And being a professor is great, by the way. We need diverse, excellent scientists to train the next generation, and they need to be diverse. So if you have the chops for that and it is your skill set, wasn't my skill set, please pursue that career, and I can help you figure out how to do that effectively as well.
Amazing. And Jasmine Benjamin, one of our panelists, has said, I heard from some people that you should always do a postdoc after a PhD because you can always start in academia, go to industry and come back, but you can't start in industry and go back to academia without a traditional postdoc. So what are your thoughts on that?
Yeah, that's ridiculous. Plenty of people know by the time they're 28 years old whether they're cut out for academia or non-academia. Also, there is no such thing as just industry. There's like 100 million different careers you can have outside of academic science training. Industry implies like pharma biotech, but there's government and nonprofit and activism and science communication. And there's just like, I couldn't even begin to list them all. There's dozens of different careers you can have. So the idea is to do the exploration during your training so that you're able to have some idea. I did not do a postdoc because first of all, I had a baby and I didn't have enough money to do a postdoc. I was very clear that that was my path. My advisor agreed with me. I said, I think I'll thrive in pharma. And he said, yeah, I think you will too. That's the kind of advisor you want that's going to be honest with you, right? And also, it has been shown that this isn't right. We need to pay postdocs better, but you lose like over your career like $1 million if you postdoc, and like a lot of money, because the salaries, as you know, are dramatically different. I'm happy to talk about salaries, be very open about what starting salaries are outside of right out of a PhD right now. Once you have your PhD, you are a scientist. And once you get into your next job, you're going to continue learning. I got a second PhD basically when I went to pharma because I moved from molecular biology to work on immunology. I basically had to become an immunologist. So I basically got a second PhD, except they paid me a lot of money. It seemed like a lot of money at the time, not as much money as you get now. But the comparator to my graduate salary, it was enough to pay for daycare. So there you go. But I really want to emphasize that that is absolutely not a thing that you have to do. And if you are going to do a postdoc and you're pretty sure you don't want to stay, it's okay to do that. And sometimes for visa issues, you have to. I understand that. Make it short and sweet. 2 to 3 years. That's my goal. My goal while I'm a postdoc is to get my next job, not to stay for a really, really long time. That's not going to benefit you, your life, your career, anybody.
Yep. Brilliant. And we've got 2 more questions. So the first one is, how do you build relationships or network with people outside of academia when you're a PhD student?
Yeah, so there's no way I have time to do that on this call. Please go watch my video. It's both on iBiology and you should go read the Hello Bio blog because I think there are lots of great tips on networking there. I don't want to defer you, but I also have video content on the Agene YouTube site that talks about networking, and both of our blogs have many, many blogs on building relationships. You can just Google me and Not Networking 101, and they will turn up. And I'm happy to answer questions through social media about that content. Basically, you got to get out there and meet people, and there are lots of ways to do it.
Brilliant. And then our final question before I hand back over to Sam, who also has a question for you, and we'll then wrap up. And I get the sense this is going to be, how much time have we got to talk about this?
Okay.
But Rushika, apologize if that is not how you pronounce your name, Rushika, how do you find your calling? Don't you think that people who have resources have higher chances to progress? And what about people who are penalized by their circumstances?
Oh, so, I mean, the lack of equity in science and inequitable opportunity is an enormous problem. I honor the people that recognize it and try to function both as allies and that are navigating it themselves. I really don't have time to do a whole talk on the inequities that lead to the diversity and bias issues and harassment and microaggressions that lead to issues in science for everybody. But how do you find your calling? So my calling was to also work on those issues all along the way, and both on a systemic level, but individually helping people through all kinds of types of programming. But I don't think we have one calling. So I don't know if you noticed my career path, but I did pharma and I worked at the bench and I managed science, and then I moved into scientific management at a biotech. That was very different. And then I moved into the business development group and started doing more on alliance management and building business relationships around science. And then I became the CEO or the executive director of a company called Agene, which I did for a decade, which involved a lot more. I didn't do bench science anymore, but I was immersed in the science that Agene supports, along with business development, finance, human resources, all the other things that I had to learn. And then I've done different things since I left Agene last year after that decade. So I think I don't see careers as going like this. I see careers kind of going like this. My feeling is I need to be learning and developing new skills because that's what makes me happy about work. You have to figure out what makes you happy about work. I will tell you that for me, working in the nonprofit space was tremendously rewarding. That isn't, doing drug development is tremendously rewarding. Helping people learn about science education is tremendously rewarding. Everyone is going to find reward in different ways and at different times in your career. So the only career that has like a very defined path is the academic career to a PI that does grant-driven research in a university. That's just one way. There are all kinds of academic positions around science that don't involve that specific path, but there are many, many paths that can bring people to job satisfaction. I hope that helps answer the question.
Yes, it absolutely does. And Sam has said that you've also answered her question, so that's brilliant. So I shall say thank you so much, Joanne, for that talk. And I will hand back over to Sam for closing comments now. Thank you so much, Joanne, and all of our speakers. Bye-bye.
Hi there. I'd like to give an absolutely huge thanks to our lovely speakers and panelists. Just amazing afternoon. They took time out of their busy schedules to share their expertise and wisdom with us in those fascinating talks and sessions. Also, a shout out to our events team, Alice and Hannah, who've worked tirelessly to bring all this to life. And I've really enjoyed today. It's been awesome. So I really hope that our first LabLife Con has given you valuable insights, inspiration, and practical suggestions, I hope, to help you wherever you are in your scientific career journey. We will email around details of how you can access the recordings if anyone would like to watch the presentations again or share with their colleagues. And we'll be posting a roundup of LabLife Con on our blog and sharing any additional resources with you. There's quite a lot of things shared with us today that we can make sure we post out there. And we've just sent a survey asking you for your feedback.